Hello, everybody. Welcome to Browsers 3000, the summit. I'm Dietrich Ayala. I'm going to be your MC and host today. Before we start in with an unbelievable slate of speakers who are working on changing this browser world that we live in, a couple of things. Welcome to the IPFS community. We're super happy to host this event, and we are abiding by the IPFS community code of conduct. There's a link here on the screen. Please treat each other nicely and be very appreciative of the folks that have come to speak to you today, as well as for the rest of this event. I'll talk a little bit about that in a sec, but this is a 6-week event starting today. So you will see a bunch of different people from a bunch of different communities hanging out, building things together. Treat each other well. So yes, I'm Dietrich. I'm the IPFS ecosystem lead at Protocol Labs. I actually come from Browserland. I was working on Firefox for many, many years. Several years ago, I went to Ethereum DevCon 4. I kept hearing language that felt similar to how I felt about the web from communities like the Ethereum developer community. And I talked a little bit about how to build bridges between these worlds. How do we bring the distributed world into the web and web browser world? Still doing that mission today at Protocol Labs. I think the power dynamic that concerned me most was pretty much this one, and that's one of the power dynamics that a lot of people that are speaking today are trying to address, and they're building amazing things to be able to do it. We use the web every day, so this work is incredibly important. We need our browsers to work for our needs, to be able to represent us fully, independently, as we live our lives online. So today, you're going to hear from a bunch of the different projects and the people that are making the web that we actually want to see. And after today, for another 6 weeks, we'll be hacking and building together the Browsers 3000 Hackathon. 6 weeks long, there will be learning sessions each week, a bunch from the speakers that you're going to hear from today. So if you want to learn more, check out the schedule on the website, and you can come and learn in a learning session, learn how to build using their technologies, learn how to hack browsers, hack the web, and make the feature that you want to see. At the end of the 6 weeks, we'll be judging the projects. There will be a bunch of different prizes, and we'll have a demo day. So we will show off your projects that you build during this time. A couple of the judges that are going to be helping us out and determine the winners of the hackathon from the projects that you're going to hear from today as well. That is through August 19th. And this is a code that will take you to the Discord. Come hang out with us there. And without further ado, I want to hand it off to our very first speaker of the day, Yuri from Puma Browser. Thanks, everybody.
Hi, folks. Excited to be kicking off this event. Dietrich is a good friend of mine who we met a while back in Portland. And I'm just gonna live dangerously and jump right into demos. So why do we start Puma, and why are we building Puma? Let me start screen sharing. At one point, a few years ago, I noticed that if you go in Safari to, let's say, apple.com, and you request a desktop website, you're gonna get the same website. It's pretty annoying. And in Puma, if you request a desktop website, you're gonna get a real desktop website. No, I'm just kidding. No, similar to Dietrich's story, I come from developer platforms. I used to work at Meteor. I used to work at Cloud and Databases Service Company, Parse. And so a lot of problems I look for from a lens of developers, and how can we build more fun things, and how can we enable more people to be more productive. And I got to know about Bitcoin early on in 2012, and then back into ecosystem in about 2017-18 through a host of events hosted by folks at Ethereum conferences. ETH San Francisco is probably one of the biggest fun events, where it was so nice to get to know the community and see what people are building. And the one thing that always struck me is that at the time, very few people were talking about interoperability. At the time, very few people were talking about bringing different crypto communities together. And parallel to that, there was a lot of conversation on privacy online, and how do you make a living online. And so to me, all those things came nicely together in a very simple idea. Let's build a browser that's is truly customer focused. Historically, most of the online content, and browsers are monetized through advertising or advertising business model. And in the Web3 world, in this new world of peer-to-peer sharing economy, I think we have an opportunity to build a much better business model where people are paying for content or apps or services and earning nice living doing so. And then the second one was, can we make a lot of crypto projects and Web3 projects really easy to use natively in the browser? And can we have the browser that is private by design, private by design of the business model, where we focus on you, and our goal is to make it easy for you to use either micropayments or some of the other projects that I'll demo in a second. And that seems like a much nicer business model for long term. And then it's also just an experiment. I'm a developer. A lot of people attending this conference are developers. And so just like the desktop website view, at the time, also 2 years ago when we started, dark themes were not the default. And so we were one of the first browsers to have dark theme by default. Now everybody has it, and we're kind of getting tired of it. But it's really exciting to experiment. Browsers your window into the internet, and we think it's a really important project. And we're excited to, one, see a lot of talks later today from folks from different projects. And two, let me demo a few things. Let's start with, let's go back to screen sharing real quick. So first of all, everything about Puma you can find out at pumabrowser.com. The project that was foundational to making micropayments happen and making interoperability happen, in our case, is Interledger. You can find it at interledger.org. And one of the applications of Interledger protocol is web monetization. It's a simple JavaScript API that allows you to stream packets of payments to a website, and for a website to react to those payments. And Uchi later today is going to do a deeper presentation about it. But to me, the really exciting part of it is that when you have a kind of like account and a balance in the browser, in case of us, it's a Coil partnership where you sign up for a subscription. You get to see, and you go to a website, you get to see this flow of events coming into the site. It's a really simple JavaScript API, which is very welcome to web developers. And so we're really excited to see what you'll build with it. And in response to this, different sites can choose to react differently. There's a game called Sushi Party that will show you no ads while you're playing a game if you're a paying customer, and it will show you ads if you prefer a free experience. Flight Escape is another fun game, which let me refresh real quick. Demo gods are not super happy today. Usually this game shows you a nice pop-up when you're a paying customer. We're going to skip that. And then one of the really fun features is that you can have a paywall unlock automatically for you once you're reading a site. And this is a demo post to make it really short, because oftentimes when you scroll down really fast, you want to be able to even see the unlocking animation, but that's all it takes for a site to recognize that, hey, you're actually a paying subscriber, and we're going to unlock content for you without ads, without any tracking. I think this is a really powerful method. And then another thing that Tishan later today is going to talk about is Handshake, and as an alternative to TLDs. And we're the first browser to natively support Handshake. Today it's all done through gateways. We're working on making kind of native resolution through having a light client in the browser, but today it goes through gateways. But this allows you to have a top-level domain like this, where you can just have Tishan, or Casey is one of the community members, or Nicole is one of the early community members. So it's really nice to have your own domain like that. And you can have a lot of fun with it. There's one project called Flamingo Handshake, which has Flamingo Handshake as their TLD, which I think is super fun and really exciting. We also have a preview of ENS starting to work in the browser. This is one of the sites as a search for INS, which is really exciting. And last but not least, from the demo part, well, obviously Hackathon 3000, really excited to be a part of it. Really excited to see what you build. Please reach out in Discord if you have any questions, or if you're building something related to either web monetization, Interledger, or Handshake. I'll be happy to check it out and see how well it works in Puma. And then last but not least, this is a preview of IPFS support natively in Puma. And this is one of the tests that developers use to check how it's working. And as you can see, this is working still early. Not all the features are supported, but it's really exciting to start supporting IPFS natively in Puma. And today, you can select your favorite gateways here. So in the settings, you have a list of all the gateways. And earlier today, some of the things weren't working, but depending on different gateways, sometimes it takes a little bit more time to resolve certain addresses. And we're really excited to launch this and be part of this ecosystem. Yeah, that concludes all the live demos. Check it out. Let us know what you think. We're just getting started. We're a very small team. We're remote first. And our goals are to bring support for all the great Web3 projects natively in the browser. And how can we onboard the next billion people to this great peer-to-peer sharing economy rather than the business model of ads and tracking. Thank you so much, and I hope you enjoyed the rest of the conference, or sorry, Hackathon, and join us in this journey. Thank you.
Thanks, Yuri. Fantastic to see a bunch of these technologies brought to mobile, which is where I spend a lot of my day. I mean, I'm working on the desktop. That's how I spend my day. Next up, I believe we have Handshake, who Yuri mentioned. Tishan, are you here? Tishan is not ready. Maybe we hop ahead to Fission.
Hey.
Hey, Jeff.
How's it going?
Good. How are you doing? Welcome.
Not bad.
Show us what you got.
Yeah, I'm going to share my screen. I was today years old when I figured out that you could share a portion of a screen in Zoom. Can you see that?
Yeah.
Cool. So my name is Jeff Griffiths. I work at a company called Fission. Fission.codes is the URL because we have cool TLDs now. I'm super excited for Fission to be part of Browser 3000 Hackathon. I've known Dietrich for a long time, and I think IPFS is cool. So what is Fission? Well, Fission today, what we've done is we've got a CLI, and we've got a CLI-driven web publishing platform on IPFS. So when you build a web app, you publish it to Fission's system, it gets propagated out into IPFS. You can check out the SIDs and see the content addressing all work. And we also gateway that to the web. And we also have a decentralized authentication system that's passwordless. I'll show that in a bit. Hopefully it works. And we have a simple, secure in-browser storage by what we call the web native file system. I'm going to show a stack diagram of how all this works or will work in the future. And so you can see the orange block is your application. We've got some platform abstractions there, which is our web native SDK. And we have some blocks in there that aren't built yet, like collaboration chat and instant sync. And in the middle, we have this durable structured store, which is web native database, which is something that's on a roadmap that we're really excited to see. But beneath it all is this durable file store, which is the web native file system. And so in the browser as a web developer, you're just writing JavaScript and fetching files from this thing. and it gets synced out from the browser and published onto IPFS. And there's two sides to that, which is a really important part of this. One side is public, so public on the web, and anybody can go to it. And there's a private side where we use our distributed identification system, our DID system, and you sign up for an account, and we encrypt your private data for you, and then publish it encrypted at rest to IPFS, which is super cool because it builds privacy into the basic layer of the system. And so on this identity side, we have password login, I said that, and decentralized auth. You get a personal subdomain, and we carry private keys in the browser using the web crypto APIs. We're end-to-end encrypted. We have versioning, so it's like think of it as like Git in the browser for storage of personal data. And you get these permanent archive links with IPFS of every known state of the previous state of your data. And this, because it leverages IPFS, it automatically syncs between devices. The building blocks of all this, IPFS, of course, a bunch of pretty cool browser APIs that we now have in browsers that seem like would have been impossible 10 years ago. But a ton of people have put a ton of work into the web platform in the last 10 years, and we're really building on the shoulders of those giant features that have been added to web browsers in Chrome and Firefox and Brave, etc. We use decentralized identifiers, and we're working actively with partners like Microsoft to standardize some of these things, and also people in sort of the blockchain world around how DIDs should work. We have a decentralized authentication specification called UCAN. We have our web native file system, and one thing I'm really excited about, getting our system to look a little bit more like a traditional Web 2 app system, having a more database abstraction on top of the data. So how does Fission use IPFS? Well, IPFS content addressing is extremely important to us. Everything needs to be portable. And so we've just built this web native API again. And so everything's synced around to different browsers that are logged into the Fission system. And the data goes from browser to IPFS infrastructure, the IPFS sort of constellation system, and then back into a browser when you log into a different browser again. So getting started with Fission is pretty easy. We're going to try it today live here. So what we need to do is install the CLI, create and link your Fission account, and create and publish an app. So I've cheated a little bit. I've already installed Fission. Ooh, that's not going to work for that. And it's got help stuff. And so the first thing we need to do is run Fission setup. And so it downloads managed IPFS from Mac OS and asks me if I have an existing account. I'm going to say no. Here's the real danger, folks. So that's my username. That's definitely unique, because you can't test a thing that when you create a thing. And so we collect an email and we do an email verification, and we're not going to sell that to anybody. That's primarily for account recovery purposes. And we're done. So we've set up the Fission account. And what we can do now is we can run Fission login. And we can switch to Safari here and sign in with that same username and link the browser. And see those numbers there? If we switch back, those are the same numbers, 102535. And so we verify that, and it's second factor. And we grant access, and we log in on the other device, and that is successful. So that was super easy, right? And it actually it worked. Thank the demo gods. And then I'm sitting here in a demo directory, and you'll notice when I list this directory, it has a fission.yaml file. We are going to tempt the demo gods again and just remove that. And we're going to run. And I'm sorry for the amount of text that this is going to punch into your terminal, into your screen here through the terminal. I'm doing it in verbose mode just so I can show you kind of under the hood how this works. We have like a local version of Go IPFS that we run and we try to connect to. And so it takes a little while to check and make sure that that's running. And normally what you would see if you didn't do -v is just like a little spinning clock, but this is much more matrixy. Just to check how old I actually am. I remember the matrix. And some stuff is starting to happen. Usually takes just about 20, 30 seconds. And it's registering the app using the Go IPFS proxy. It's asking me which build director I want. And so if I run npm run build, I'm good. And then if I run again, apologies for the sheer amount of text that's going to go whizzing by. We're going to publish this to the web on a brand new domain, which we do auto-generate these domains. So this app is called Skinny Petite Round Gnome, which is interesting. We have like some sort of Markov chain-esque URL generator that somebody wrote last year that's very clever. And so it's sort of doing the same dance of getting the CLI working and running with Go IPFS here. And then fingers crossed. Oh, we're starting to see some stuff starting to happen. And we're connecting to the IPFS network, publishing to remote, and we're done. So if we copy this thing here, and we switch back to Safari, on the right URL, it's hello world, and that worked. The demo gods were generous, probably because I've been praying to them a lot. So next steps for Fission for this hackathon. So we've got the Fission guide. I've got a URL here. What you would do with this app next is you would hook it up with the Fission authentication system so that someone who comes to your app can sign up for a Fission distributed ID account and use your app and store their data for themselves in their browser and IPFS without you having to run storage or an AWS account or anything like that. And everything gets stored in web native on behalf of the user. It gets encrypted at rest, and then you don't have to run a database with 1 million users in it, which is pretty cool. What's next for the hackathon? We've got fabulous prizes. We've got a sticker sheet, we've got t-shirts, and they look pretty cool. And so best use of Fission, we're actually going to ship someone 1 liter of maple syrup. Fission is a distributed company. It's located around the world, but there is a bunch of Canadians and we like maple syrup, plus a t-shirt and a sticker sheet. Runner-up for best use of Fission Web Native, t-shirt plus sticker sheet. And honorable mentions, you get is it sticker sheets. That's a link to the swag shop that we have, but this will be for the winners, shipped free of charge worldwide. And come talk to us. During the Browsers 3000 hackathon, we've got a hashtag Browsers 3000 channel on our Discord server. Just go to fission.code/discorder. It'll get you to the right part. Tell us what you're trying to build, talk to us. We're going to be manning that channel. We use Discord for our main communications anyway, so we'll always be there. And thank you very much. That's the wrap up. Back to you.
That's a lot of maple syrup.
Well, now we have to source 1 liter of maple syrup, but I think that at a previous hackathon, they actually found a 4-liter bottle of maple syrup and just said, let's just make a prize out of this. But we didn't want to have to depend upon that sourcing. So
I think we're going to have to crowdsource ideas for what to do with that much maple syrup. Maybe that comes naturally as a Canadian. I will ask you for advice.
yes. And
alrighty. Yeah. Oh, yes. Next up, I think we have Uchi from Web Monetization Coil speaking, and then we will put Handshake on after them.
Awesome. Thank you. So I'm going to get started here. I'll share my screen. But before I do that, a little bit about me. So my name is Uchi as in Gucci. And before Coil, I worked in the decentralized identity space, working on deeds and things like that. And I'm really excited to be able to showcase web monetization and also talk about the COI prize at the Browser 3000 Hackathon. So sharing my screen. Awesome. So as part of this talk, we're going to really go through how we can hack and earn with web monetization. And the goal is to really see some example projects that have already been worked on and how we can get started with web monetization. And if you look at this line of code, if I told you that this line of code could enable you to start earning in real time from your web app, would you believe that? So imagine that you just add this on the head of your site, and automatically you get paid into your wallet. It could be that you want to receive your payments in USD or other cryptocurrency. So the person that's viewing your website is going to be paying you directly from the browser agent. We're going to see how all of that works in a bit. But first, why do we really need a different business model for the web, right? There's ads, and there's already ways for people to make money on the web. So why is web monetization or a different strategy necessary? So there are a couple of reasons. And one of it is that currently, if I'm a developer and I write lots of amazing blog content and I want to make money from that, I might have to add ads to my blog, which is annoying. We all don't like ads. Those pop-ups are very annoying. And also it's controlled by a few entities, right? And there's really lack of privacy when we browse ad focused websites. Also, there's also a delay in payments. So from when the payment goes from the user to the content creator, there's a delay, right? And that's why the second part of the slide talks about a more fair, transparent, and open way of making money on the web. And this kind of approach is driven by the value provided by the content creator. And the content creator could be like a developer that writes about getting started with the web or things like that, or maybe a developer that does tutorials. And how can they really make money from those tutorials, right, in real time, in a way that they are receiving the payments in like micropayments, and they can spend it instantly. And this is possible. The second part is what we all want, and it's possible with something called web monetization. You already talked about this already. So he showed how it works on the Puma browser, which is super cool. And with web monetization and the Coil extension, you can also enable real-time payments from your browser to web monetized websites on any browser, as far as you have the Coil extension. But with time, the goal is that web monetization should be native across all browsers, so that regardless of what device you're in, you should be able to browse content and enjoy content without the need to see ads. And you should be able to support the content creators that are providing value to you. So let's see how it all works. There are a couple of components that make this possible. And the first one is the wallet itself. So this is where you receive your payment, right? Because you don't just want to receive payment and not be able to spend that payment. You don't just want your payment to go to thin air. So you need a way to hold the value or the money you're receiving. And the money, it's currency independent. It doesn't have to be in USD. It doesn't have to be in Bitcoin. It doesn't have to be in SRP. It could be on any cryptocurrency, depending on the wallet provider that you choose. So first, you need the wallet. You need the payment pointer. So I like to describe the payment pointer as an email address, right? So in an email address, you're getting data packets. And that data packet could be text, it could be videos, it could be audio files. And you get that data packet delivered to your email. And for the payment pointer, it's like the email too, but the only difference is that you're getting payment packets. And these payment packets could be any currency, right? It could be received in Bitcoin, it could be received in USD, SRP, or other cryptocurrency, or even things that are not cryptocurrency, depending on the wallet provider. So yeah, think about the payment pointer as your email, and it's unique, right? So the payment is being sent to your payment pointer. I'm going to show you how to get one in a bit. And then the last part is the HTML meta tag, which is what I talked about before. So this you add it like so in the head of your browser. Once you've done that, anyone that has the web monetization subscription or anyone that uses Puma browser and is signed in is automatically going to be paying you when they are viewing your content. So let's see how all of that works in a bit. But before we do that, we're going to look at a few websites that are already web monetized. So Free Code Camp is web monetized. Hackathon is web monetized. Default, dev.to, and all of these other websites are web monetized. And the interesting thing about how web monetization works on dev.to is that the payment actually goes to the writer of the blog post, right? So if I have an account on dev.to, all I need to do as a writer on that platform is to add my payment pointer, which again, think about it like a phone number. I add it on my profile. And when someone is viewing my blog post on dev.to, I'm automatically getting paid, right? And this payment pointer can be added to any website. So there's also support for web monetization on WordPress, and even like any website I have. So as far as I can change the head of my site, I'm able to receive a payment in real time. And I'm just going to do a quick demo here. So I'll switch to my VS Code. I hope you can still see it. So this is simple. This is a simple project. It's just a web website that I'm working on for the workshop that we're hosting. So if I switch back to the browser, you'll notice that if I click this coil extension there, it says that this site isn't supported, right? So that means I don't have web monetization enabled yet. So let's see how easy it is to add web monetization to this site. So I'm going to switch back to VS Code, and I would copy the line of code I talked about before. And then I'm going to, so I'm going to add that to the head of my site there. And once I've done that, I save. When I save, this is going to refresh, and I go back to the browser. So now it tells me that Coil is paying. So just by adding that line of code, the developer of that website, in this case, which is me, I'm getting paid in real time while I view the website. Also, right? And that content, dev.to is getting paid too. So this is how it works. And I think the potential of web monetization is really huge. We're going to see some examples of how you can use web monetization. So switching back to the presentation mode. Again, we talked about this before. You are able to set up a wallet, add a payment pointer to your website or your web app. Like if you have a hackathon project, for example, and you want to add web monetization to it, you can do that by adding one line of code. And also you have the option of redeeming some Coil credits, so you don't have to pay for the Coil subscription for maybe 6 months. So you can go to coil.com/redeem or reach out to me and we'll get you set up. Okay, so what can you build today with web monetization? So there are a couple of things that you can build. And one of it is you'll be able to build a web app, for example, built in React or other frameworks that unlocks new features for web monetized users. So take, for example, the sushi party game that Yuri showed before. Imagine that you are the developer of that game, right? And when someone that is web monetized views that game, you maybe show some additional illumination or like a thank you as a result of them being web monetized. And also you can gamify your app also when someone is paying via web monetization. And then imagine a scenario where you have multiple contributors of content. You're able to do something called probabilistic revenue sharing, whereby each content creator is getting paid for the amount of contribution that they made to that content. And that's kind of what dev.to does. And there are lots of business models that you can work on for sharing content, for sharing payments to multiple users. And something I found really interesting today while preparing for this was a way to create an IPFS, web monetized IPFS viewer. So I saw a couple of IPFS viewers, and I think they are really cool. So I think it'll be fun to have some of those web monetized and maybe discover or unlock new business models by combining IPFS and web monetization. So I think that's like an interesting experiment that we'd love to see someone at the hackathon build, and I think will be really cool. And then also with Puma Browser, a combination of Puma Browser plus web monetization would also be cool. So imagine like a progressive web app that can work offline on mobile that can be opened by Puma Browser. And when a user is web monetized, they get paid in real, the developer of the app gets paid in real time. So I think that's another use case that might be cool to explore at the hackathon. Okay, so what are the next steps to kind of get involved more with web monetization? So the first one is the hackathon. We're going to have the COIL prize for the best web monetized project. So join the learning session that we'll be hosting at the hackathon to learn more about that prize. And then the second way to get involved is by participating in a workshop that we're having. So we're going to have a web monetized workshop. And then the third way is the grant for the web. So it's $100 million grant that supports projects that build with Interledger and web monetization. And then the last way is by contributing or following the work that we're doing with Rafiki. So Rafiki, it's kind of the next generation of Interledger that will enable more wallets or that will enable interoperability between multiple platforms or multiple networks, big blockchain networks, and Interledger. So I'm looking forward to like seeing more people contribute to that and seeing lots of wallets adopt or enable Interledger. And I talked about this before, the COI prize for the best web monetization project. So please join the learning session that we'll be hosting to learn more about this prize. And then finally, all of the resources that you need are at developers.coil.com. And then webmonetization.org is where you want to go to learn about all of the details of web monetization. So we have the specs, the specification there. So actually, web monetization is a proposed W3C standard. So it's hopefully going to be in all browsers in the future, and that's kind of where we're working towards. So you see the specification of web monetization, you see documentations, and you see some help docs also. So that's all for me. If you have any questions, please feel free to ask in the chat. If not, I'm going to pass it on now. And I'll stop sharing my screen also.
Thank you so much. The first step to throwing off the shackles of surveillance capitalism is having alternatives to choose for how we interact online. So I'm super, super excited about some of these APIs and approaches and what folks like Gucci and the Quill Project Web Monetization API are bringing. Now, our next speaker, Wav, very excited to introduce somebody who's really built the browser they want to see in the world, and that's Agregore. Welcome.
Thank you. Let me just share my slides. Yeah. Hello. I'm Move, and today I'm going to be talking about IPFS in Agregore. I'm mostly going to be talking about my love of the web, peer-to-peer networks, and how I've combined these in a web-like interface. So I Move, or everywhere on the internet, I'm at Ranger Move. I do consulting on peer-to-peer stuff through my company, Move Software Inc., and I am high-key obsessed with peer-to-peer and local first software. So I just want to start out by talking about how I think the web is good. I really just love the ability to get started with making a little web app, just throw some HTML and JavaScript on a page and make something, and also not have to worry about cross-platform issues. When I was first learning to program, it was actually a huge deal to actually share my code with anybody. And once I got into web development, suddenly I didn't have to worry about what platforms people were running, whether they even wanted to install my binary or not. I could just create my content and the web would do the distribution for me, which is great. Sadly, the web is tightly coupled with these things called web servers. And I think that web servers are kind of bad, or at least not as good as they could be. Oh, let me just fix the formatting. Oh. And, you know, this is better than having no web since, you know, at least we have a web, but having web servers actually introduces some new problems that we didn't have with just, you know, native software. So for example, if you want to actually get your software to scale really well, it's really hard. You need to have a whole bunch of engineers doing a whole bunch of work to get a whole bunch of servers to do a whole bunch of stuff at once, which, you know, is expensive. As well, it makes security harder because now you have these large databases of people's data. And if there is a leak or if some programmer doesn't do something right, suddenly everything is exposed, which is not really great. As well, you now need all of these concepts to learn. Whereas before you can have like, I don't know, a Visual Basic script, and that could give you like a super basic GUI on a computer. Now you need to know not just the code for rendering, but you also need to know how to do databases, how to do servers, and how to make all of this stuff interop with DevOps, which is not super accessible to a lot of smaller groups. As well, you know, this might be a little hard to think about, but you need the internet now to author content, to load content. And if you want anything to work offline without the internet, it's super hard. Similarly, if I want to load a file or share a file with somebody else, I suddenly need to not just connect to them and send it, I need to connect to a server who knows where, and then they need to connect to that server. And this file that could have been sent over my local Wi-Fi now needs to do a trip around the whole world, which adds latency and just general waste. As well, with server-based stuff, you need to constantly pump money into it to keep it going. So that means that you need a credit card and an address. That means that if you don't have the ability to set up your own hardware, you need to now rely on some third party and make sure that they never go down or they never change anything from under you. So that's kind of hard because suddenly you have a lot less control over what you can do. However, there is this cool thing called peer-to-peer, and it's good. So it's been getting a bit more popular lately to think about how things can work without servers. So peer-to-peer software is really interesting in that rather than having everything aggregated in a central place, we can instead have everything spread out across all users. And this comes with some cool trade-offs that we didn't have before. Everything now works offline first. So if I publish a little blog with my cat photos or whatever, if anyone's downloaded it, they now have a copy of it that's available offline. And I didn't need to do any crazy engineering with service workers or like complex stuff. Everything just works by default, and you don't need the extra setup for servers unless you really need to. In fact, authoring a peer-to-peer app is a little more simple in that you can have some files in a folder, and that folder is some sort of peer-to-peer archive or peer-to-peer thing, say on IPFS or MadeSafe or BitTorrent or Hypercore protocol, whatever you're using. And suddenly that could be an app, and that can be transmitted the same way that you transmit data, say like a Linux ISO image, because that's what people use torrents for. And also what's interesting is this stuff could work without any sort of third party mediating your access to data and publishing. So instead of me having to rely on Google to host my blog spot or whatever, I can rely on just my computer being online, or having like a little cell phone sitting in the corner that is now my website, or keeping my website online. As well, it all works without needing the internet, but potentially over local networks. So imagine you're trying to go on a camping trip with your friends, and suddenly absolutely nothing works anymore because you're just out of range of cell towers. And all of the software you have, even if you have battery power, it's kind of useless because it all relies on the internet and the cloud. But if your software was built on peer-to-peer, suddenly you don't have to care about the internet or the cloud or whatever else, because any device that's within networking range could enable you to communicate. So that's super cool. But what if we went one step past having peer-to-peer apps that are native and thought about peer-to-peer web? So what would it look like if, instead of having servers serving web content or peer-to-peer apps that are natively installed, what if we instead had our web browser that could just load content? And there's been some stuff already around providing JavaScript APIs in web browsers to interact with peer-to-peer content. But what if, instead of having these JavaScript APIs, we thought about what would the HTTP peer-to-peer web look like? So let's just quickly go over what HTTP looks like. We've got URLs, which everyone loves. We've got some methods on what we can do with the URLs, like we can get something from a URL, post something to a URL, delete something. And with HTTP, we can load content. So we can load web pages, we can load images, scripts, all of that good stuff. And we have JavaScript APIs for reading and writing stuff from web servers. So what if the peer-to-peer web was the same thing, but instead of using HTTP URLs, we could use IPFS and IPNS URLs. So for example, what if we could get data from IPFS and some sort of hash or path to get content from IPFS, or similarly with IPNS? Or what if we could post to IPFS, the protocol itself, and say, give me back a hash that I can share with somebody? As well, what if publishing a website on IPNS was as simple as saying publish to an IPNS URL? So that is kind of what I was thinking about when I created the Agregore browser. So initially, I'd been working on some Electron-based apps for clients, and I created some protocol handlers. And I was looking at it and I was like, wow, this is actually super easy. And so the thing that I wanted didn't exist yet. I didn't have a browser that could do all of the protocols I wanted. There was nothing that was, as minimal that I wanted, and nothing had support for extensions that I could see. So I set out to make that. So Agregore is an Electron-based peer-to-peer web browser, which has support for a whole bunch of protocols. We have IPFS, IPNS, of course, Hypercore protocol. We have support for weird things like Gemini, and in fact, we have support for BitTorrent. So any BitTorrent magnet or info hash out there is actually already a peer-to-peer website, which is exciting. And as well, rather than trying to pack as many features as possible into the browser, instead we use web extensions. So the same way that you can extend a regular web browser, you can now extend your peer-to-peer web browser. And what's cool is all of the extensions have access to all the same APIs, that regular web apps can. So this means you can easily create things like peer-to-peer synchronized bookmarks across your devices, or interesting things that I haven't even thought about. So I'm going to tempt the demo gods and show you what it looks like to actually interact with peer-to-peer protocols in Agregore. So I'm gonna open up my console. For those of you that haven't done much of this console stuff before, it's kind of like the backdoor to doing stuff with websites. So with the built-in web APIs, you have this thing called fetch. And fetch lets you either fetch data from a web server or post data to a web server. There's some older APIs called XML HTTP requests, but those are a pain in the butt to use, so pretend they don't exist. So what I'm going to do is I'm going to show you how I can get data from IPFS. IPNS://IPFS.io. So if I specify an IPNS URL in Agregore, it's supported out of the box, and I can request some data. In case I want to actually view the data, I'm going to fetch it. Oh. All right, bam. So I just downloaded the IPFS, the IPFS.io homepage, and I've got it out as a JavaScript string. So in your application, you could see this fetching things like users' profiles from their URLs, or something to do with decentralized identities, or some sort of data that you might want to aggregate in, say, a social application. Similarly, if your application wants to post something to IPFS and get back an info hash, rather than using the IPFS global or importing some sort of libraries, you can use the built-in browser fetch API. And instead of doing a fetch to an IPFS URL, I'm going to fetch an instead of IPNS, IPFS URL, and I'm going to give some sort of file name. For example, I'm going to say I want to create example.html, and I'm going to post some data, and the content will be the body, which just has a header that says hello world. So now I posted that, and it uploaded to my local IPFS node. And if I copy this link, I don't have anywhere good to post this in the chat, but if I post it in the URL up here, I just created my website with hello world up here. And so with that, I can publish arbitrary things to IPFS. Say I wrap this in a marquee tag, and now I get a new URL. But what's cool is with pretty much very little changes, I can now publish this into an IPNS domain. So again, I'll use fetch, but now instead of fetching an IPFS URL, I'm going to fetch to IPNS and make up a name for a website, for example, example. Under the hood, this will generate a public-private key pair, and it'll generate a new IPFS public key URL. And instead of using the post method, I'm going to say publish. And instead of some HTML, I'm going to post the IPFS URL I want to publish. More specifically, I'm going to publish the root folder rather than the example page. Oh. And now if I paste that IPNS URL, it's automatically resolved to this IPNS-based website. So if I had named this index.html, that would be automatically loaded, but here I can load the file itself. So that's kind of all of the pieces that you need to get started with using IPFS inside Agregore. So with all of that said, I am going to be doing another session on, I think, next Thursday, where I'm going to be showing people in depth how to actually make something with this and doing a bit of a workshop where you can play around. I'm going to be giving out some stickers as prizes for people that do interesting things with Agregore or with combining multiple protocols together. And if you're ever interested in learning more about this or have some questions, I'm going to be in the Discord for the Browsers 3000 channel, or you can join the Agregore channel, which I will link somewhere through my slides. But yeah, I hope this is giving you some ideas on new ways to interact with the web and with peer-to-peer protocols. I hope you can make stuff, simple, you can make stuff that's resilient. Thank you.
Thank you so much. I like the idea that making the web that you want can be simple and resilient. And it's a thing that you can do, which is fantastic. Next, we have Makoto from ENS, who I met some time ago and got to hang out with at IPFS camp, which seems like a long time ago now. But also ENS is one of the first services that actually is a distributed naming service that supported IPFS. So love to hear an update about where things are at and what we can do today.
Hello, hi. Yeah, I'm Makoto. Thank you very much for letting me to talk about ENS. So let me share my screen first. Apologies in advance if you start hearing lots of noise. I live next to busy road, and sometimes like all the motorbikes and all the stuff gets a bit noisy. But let me start now. Okay, so yes, so ENS stands for Ethereum Name Service, and I usually talk at like Ethereum blockchain related conference, and I'm aware that this is kind of just beyond blockchain Ethereum. So I'm trying to do the quick introduction of what Ethereum, ENS is that like if you have any cryptocurrency. In this case, Ethereum wallet, you usually have this kind of hexadecimal address, which you can send or receive cryptocurrencies. And usually this is quite hard to basically remember or even tell to the other people. So what we offer is a very simple naming service. For example, matoken.eth is my ENS name, so that if you want to send me some ETH or any like ERC20 tokens, you can send to matoken.eth. So this is a very gist of what ENS does. However, we launched back in 2017, so almost like 4 years, and now we have over 250 wallets, exchanges, and various dApps. We call it dApps in the Ethereum space, which is kind of equivalent on the web in I think IPFS world. Many application supports, and what ENS underneath is, ENS is not part of the blockchain itself, but it's actually built with a smart contract, which is a unique feature of Ethereum, where you can write a program which controls the flow of money. And famous application in Ethereum is something like an automated market exchange or like some lending platform. But we use the same basically programming language to build a basically net name service, which is one of the probably simplest form of smart contract. It's just like key value like a dictionary. So we have something called ENS registry, where you ask for what's the address of, for example, foo.eth. And what it does return is actually, rather than just returning the crypto address straight, we return something called resolver, which is in charge of actually storing the record. And in the first example I mentioned, it returned, in this example, it returned the same address. But this resolver is very extensible. Anyone can write your own resolver and they add support. So it's really extensible. And in today's talk, I want to basically introduce kind of two different use cases of different record types you can store and make use of for the other cryptocurrencies and for the web purpose. And also I wanted to extend a bit of idea of the Ethereum address, not just for kind of wallet, but more as a kind of public key infrastructure. Oh, I found a typo. Yeah, anyway. And also we have a very small price for the 5 best project to integrate with ENS. And you can just do normal integration of just like doing the name lookup. But like I think I put a couple of ideas throughout this talk, so like hopefully it can inspire you to add into your project. And first is other cryptocurrencies. So yeah, ENS, most people's assumption is that you can only kind of map into Ethereum address, but in fact, it actually supports over 200 different crypto addresses. So one use case is that, for example, about 3-4 months ago, there is there's a second outbreak in India, COVID, and there's a guy, this Sandeep, who is a founder of Polygon chain, one of the kind of side chain of the Ethereum, basically asked for the donation and saying like, hey, can you donate to, and then like to reach out to as many different kind of audience that he put like, hey, just do it on Ethereum address this, BTC address this, Doge address this, Tron address this. Then like it didn't actually even fit into the the tweet. And so what we actually reached out and they made it together is just set up the ENS name called covidrelief.eth, where we put like all these different Ethereum addresses such as ETH, BTC, LTC, Doge. Yeah, and it does also support Filecoin, FIL. So like if you want to do in the hack, like if you basically want some system to send Filecoin, you could actually use ENS as well. But just to bear in mind, like this is a name storage. So like if you people has to send a Filecoin, your DApp has to integrate Filecoin wallet, I think. And the second use case is the web use case that yes, we not just storing crypto addresses, you can put so-called content hash, which is defined in the EIP 1577. And the majority of the time, people put like IPFS, IPNS, CIDs, but you can also put other distributed file system like Swarm, SIA, and also you can put Onion address or anything which actually supported in a so-called multi-codec standard, which is just one gigantic text file, and it has like I think not 100 but quite a lot of them. But in our apps side, we only kind of support all these 4. And I'm assuming the most audience here knows how to kind of upload asset into the IPFS and get content ID. If you are aware of it, you can just go to our dashboard and copy and paste the address there. But like if you are more like traditional Web 2 developer, what I do recommend is use a service called Fleek, which is a kind of CI, a continuous integration service provider. But they, as part of basically deployment, usually there's a normal flow is that like if you merge your branch into master, it automatically kick in kind of deployment flow. They natively supports ENS, so you can, and they actually set the IPNS hash for you. Okay, and once it's been set, first use case is if you have any ENS supported browser such as Opera, Status, which is a kind of Ethereum crypto wallet, and the messaging system, and also for I think Brave and Chrome, you can install Firefox, and you can type like, for example, ens.is, and it goes to this site. But I am aware that not everybody has like MetaMask or use Opera. So we do this is a work we kind of did thanks to the grants from the protocol lab, is that basically our colleague extended a DNS server called isDNS, so which is served for .eth link, which we own. That if you kind of append .link after, so like ENS is link, it actually basically shows redirected, not redirect, it serves the IPS underneath, and all this is done thanks to the Cloudflare underneath, so that we don't have to handle the huge traffic and the stuff. And yes, and just to know, this only applies to IPFS, IPNS, not for other file distributed file system. And but then you might think, oh, okay, so ENS, so EastLink is owned by you guys, so it's kind of centralized. But again, IPFS gateway, like IPNS.io is just one of the gateway. So you probably know that there are many different gateways, and actually IPFS gateway natively supports ENS, so that you can go to ENS -east.pns web, IPNS web link. Or if you go to other gateway, you can do is ens.east. One thing is if you go to that web link, because you can add IPENS as a part of the IPFS address, but because you don't, they replace the dot with dash. That's only gotcha. And the last part is a bit abstract, but I'm trying to explain, is that, so not just for Ethereum, but it's kind of side effects of popularity of crypto for the last few years is that actually it's not just gave people wealth, but it actually gave people a public-private key. This is a tweet by Bradley, who is my colleague at ENS, and he said one of the most is that public-private key. And if you're not familiar with what it means, is that for example, on the right side there, the Ethereum address. The address is actually derived from the public key, which is hash of the public key, which is also hash of the private key. So by not the Ethereum address itself, but if you look at the transaction, you can basically derive the public key. So you could use the same thing as a kind of key signing, which is kind of interesting that, oops, I skipped, I think. Oops. Yeah, so that since I don't know, 1890s, many people try to kind of promote the use of email encryption or using the digital signature, but even though some people uses it, it's not widely used. However, with this rise of crypto, suddenly, gave the public key, private key through crypto addresses to the millions of people. And then one of the important thing is your key is, no one manages your key. So you really have to take care of all the, make sure private key is not given to anyone else, that kind of stuff. And then people learn very quickly as soon as they have sizable chunk of wealth under their wallet. And also recently there's things called non-fungible tokens getting very popular, and many people who has nothing to do with cryptocurrencies, artists jumping into this NFT bandwagon. And the first kind of misunderstanding everybody thinks is you put the image, my art, into blockchain. Actually, that's not true. Most of the time, people put that into IPFS. But what blockchain or Ethereum offer is the fact that you, who holds a public-private key, signs this digital art that this is kind of minted by me. It doesn't prove it, but it's just you sign it. That's a big difference. So it's people start using not just for the coin transfer, but basically using to prove their work. They already start using it, and then by extending this idea, Bradley kind of suggested, like, even if you don't use cryptocurrencies, you should still use like a Ethereum wallet just to sign in, so that they can just sign that, like, I am the owner of this public key, and just use this Ethereum address as an identity. So that this is a kind of idea he tweeted. It got very popular. Yes, I think I'm running out of time. I only have 2 minutes. So this part I go through very quickly. And last part I'm going to introduce is like I've been all talking about .eth address, which is kind of decentralized one, which only exists outside of the internet, which you have to register. But because many of the brands' name are already kind of squatted. So if you like Amazon, Google, it's all squatted by, not by the brand holder, but like squatters. Then if these people want to make use of this kind of signing capability or just as a quick wallet, they can't use the name they want. But in that case, we actually provide ways to use domain name, internet DNS name as ENS name. So in this example, you are actually this islab.xyz, which is the internet address, and suddenly it does tie into Ethereum address. And I tried to explain this, but like I think I'm running out of time, so I'm going to skip it. But like if you want to, well, key important thing is you can do it in a non-trusted manner. We have something called DNSSEC Oracle as a smart contract. So you could actually use this smart contract and make useful for whatever the project you want to do. And as a summary, so I went through some of the usage of ENS outside of kind of Ethereum space. So even if you are not working on like blockchain Ethereum directly, these things you could still do. And if you're choosing the top 5 project, you could win a bit of bounties. Like one, basically add login with Ethereum into your site, so that people can just sign the signature. And important thing is this is just a sign in a message, so these people don't have to have Ether or any cryptocurrencies. And also, turn your internet domain like DNS name into basically pub private key, which I just showed using that using your internet domain turning into DNS name. Then also, if you do support Ethereum address into your project, you could actually add other cryptocurrencies. And probably this is the last part is most common usage for this hackathon participant is that I assume you use IPFS somewhere, and then once it's added, then you just point to, and if you use IPFS to host a website, you can point to ENS name using the content hash. And so that's it. And if you want to have more, find out more about how exactly you want to use ENS, there's a docs ens.domains, and we have a Discord channel, and we are scheduling the kind of interactive Q&A session next Monday. We don't have the time yet, but like just stay tuned. So like just dive into ENS this weekend. If you have any questions, just bring it to me, and then we can just talk about it. Thank you very much.
Thanks, Makoto. This and other naming systems we're hearing from a couple today, I think are fascinating for me because before people, some people were like, hey, you can do it all with DNS, right? But one of the differences is highly programmable naming systems is what we have now. And that brings that power down into the application layer instead of making application developers turn into infrastructure developers. So it's super, super powerful. These examples are great. I recently asked about building a distributed gravatar on Twitter, and somebody was like, hey, ENS already supports avatar records, which is super cool. So really happy to have you here. Thank you so much for sharing.
Thank you very much.
Next, we have Brian Cardell from Igalia on a video he recorded, and the work that we do with Igalia, we've been working with them for a couple of years. If you don't know who they are, I'm not surprised. They are not a browser vendor. They're not a mega billion-dollar company. They're a name that very few people have heard unless you actually work on the web platform itself, where Igalia has, they are committers to WebKit, Chromium, and Gecko. So we work with them, and when we encounter paper cuts in the web platform, either inconsistencies in the security model of the web, interoperability problems or compatibility problems in browsers that prevent us from doing distributed web work, we work with Igalia to get those problems fixed. And that not only helps IPFS, but it also helps all of the other alternative non-HTTP protocols that are trying to work within the context of the web platform today. So this is very important work, and it's really a pleasure to be able to have Brian explain what Igalia is, what they do, and some of the things that we've done together.
Okay, so I'm Brian Cardell. I'm a developer advocate at Igalia. This is my domain if you want to learn more about me. And I'm going to talk about decentralization, and not just the distributed web, but also this other kind of centralization, which is that like everyone relies on the web. There are thousands of organizations built on these foundational web standards. There are hundreds of orgs that participate in standards bodies that make them, but then there are, historically even fewer that make a browser, and even fewer still that make a browser engine. So we talk about these browser vendors, but we don't talk very much about, how they have budgets and where do those budgets come from, and the fact that those budgets are managed and spent in the way that software projects are. They have different departments with different managers and people with different skill sets, and everyone is trying to manage them independently, and it's only ultimately a standard if everyone makes it through all of the gauntlets. And so things get really backed up, and vendors are, less likely to take the time to diverge from working the current backlog or things that they already think are important to discuss new things, especially big things that would, involve hard problems like decentralizing the web itself. So, we all wait and we all hope that they do it. We lobby them to do it, but ultimately this is also a feedback loop, and, things just get worse. So even small things can wind up lingering without a final implementation, which costs us all, which really kind of sucks that we've created this, sort of centralized choke point of where we can progress. So I'm super grateful that we have gotten this far with that model, but just imagine that we could fix this, improve it. Well, we can. And the reason that we can is because things have gotten progressively more open. Over the course of the lifetime of the web, we've gotten to the point where all of the standards implementations are now open. And to illustrate why I think this is important, I don't know if you are familiar with CSS Grid. When it landed in 2017, everyone was like, wow, everybody did it, and it's magic, and it's our favorite thing ever. People still talk about it in my timeline on Twitter every day. But this has origins going back to 1996. There were failed attempts along the way, but this time it worked. What was different? Well, in fairness, multiple variables, but really one core critical one is that things are open, and so other people can contribute, and that is what we did. Igalia did the work to contribute 2 implementations of CSS Grid. We did that with funding from Bloomberg Tech, so thank you for that. But what I'm trying to point out here is that a lot of things aren't sort of stuck over politics or these big strategic gyrations that we imagine. There's way more practical things. They just can't get prioritized. This is very mundane sorts of things about prioritization that hold us back a lot. And that's what Igalia does. We are cooperative of developers all over the world, and we specialize in web browsers. We're trusted committers everywhere, and we contribute to all of the engines. And when I say we contribute, I mean we contribute a lot. These are just 2 graphs that I have handy. The one on the left shows our contributions to WebKit, where the orange, the light blue is Apple. You can see what a big slice of the pie that is. On the right are the last 2 years of commits. These do not include Google in Chromium, but they do include everybody who isn't Google. And you can see that the blue is Igalia and the red is Microsoft. Now, Microsoft will probably pass us up, but just to give you an idea of the level of commitment that we're playing in multiple browsers, all of the browsers really. So it's pretty significant. We work on all of the standards bodies, and we help bring priority to things that browser vendors can't prioritize themselves. This has been really successful. If I create a list that would fill several slides, but here's just a couple that I think are fun that we've done in the past year or so. And another thing is we love the hard problems. We love the big problems, things like MathML. MathML is really historically unique. It and SVG are two things that are actually directly integrated into the HTML parser. But it was in a really hard problem, and Egalia's really helped with that. Other things like container queries, Igalia really helped move that conversation by giving it priority. Everybody's really excited, including us, about Miriam Suzanne's work with Google. But our proposals and prioritization helped push that from the outside a little bit. And in fact, we demonstrated a working prototype in Chromium the same week that they announced taking up the better proposal. So also has, which is like parent or ancestor selectors, have been in and out of CSS selector specifications since the late 90s. Nobody has been willing to touch that because it seems like impossibly hard. But Igalia has a working prototype in Chromium that was funded by IO. So we think that's like fantastic. We're excited about that. So what I'm trying to say here is like, this is a really good thing. We can accomplish great things if we work together. And that's great because we all move forward together. So it is kind of a commons that we should all try to play some kind of role in. And we don't know what kind of roles we can play until we talk about them. So I have a lot of thoughts on this. In fact, I have a podcast, Igalia Chats, where we have an entire series on improving the health of the web ecosystem. So if you're interested in that, check out a lot more. But really key to this is thinking about how we expand investment and prioritization, the ability to prioritize beyond these couple of very few vendors. So one way that we're able to do that is we are the maintainers of WPE, which is the WebKit port for embedded. So if you go to webkit.org/download, you'll see it there. And it powers like billions of embedded devices. So, well, why does this matter? Well, another example. So if you don't know Sarah Drasner, she is an SVG guru, enthusiast, expert. And she's long been a proponent asking for hardware accelerated SVG. This is actually a really difficult problem technically for reasons you can listen to on our podcast. But is very difficult to prioritize because for a lot of the web, SVG is not sort of the top priority. But this work is coming to WebKit, and the reason that it is coming to WebKit is because of cooking machines. Well, not exactly just cooking machines, but all embedded systems. So this is the Thermomix TMZ6 by Vorwerk. And that little screen on there is an embedded WebKit. All of these things in, car infotainment systems and video games and televisions and, appliances and digital signage and point of sale, they're all using the web to make their interfaces. And what's interesting about embedded is that it is actually of core importance to have hardware accelerated SVGs there because these devices are less powered. They all have a GPU for the most part. And the kinds of interfaces that you frequently want on these are more SVGs. So that's really important. And we're able to help bring new investment that will benefit everyone. I think that's great. But also just why do we even have the model that we do? Like why should even a single organization have to fund the development of a standard? Maybe that doesn't always have to be the case. So we also ran this experiment last year that we will probably continue called Open Prioritization, which is a partnership with Open Collective in which we collected funding from many sources to fund some work. So we think that's really interesting. And we hope that that helps sort of decentralize the ecosystem of investment and our ability to get things done. So, okay, but decentralizing the web itself, it's a big challenge. It's the kind of challenge that we like. It's a big challenge for a lot of reasons. And all of these reasons, pile up, and each one independently is subject to all of these prioritization filters and budget constraints and things. And so the investment from, the main browser vendors might not be as great as everybody would like. But that's okay because we can supplement that. And so that's what we've been doing. We've been working with Protocol Labs. Protocol Labs has funded a bunch of work in this area from Igalia. We have worked on improving register protocol handler. The HTML specification neither matched implementations nor allowed for some usefully workable definitions. And so we sent patches for things like making sure URLs are well specified and that they work. Then implementations in Chromium for like how do we define like what are the safe URLs that you can register? What are the safe protocols? So we're still sorting that out. We landed this pull in Chromium that adds the distributed web protocols, and we have an open PR for HTML for that. Along the way, we have done just tons of fixes of things like service workers and URL encoding and parsing for how these interplay in protocol handlers. But also, there's just these bigger ideas like secure context and potentially trustworthy, where like the specs are built, reasoning about the web that we had. And so sometimes things need a better definition. So these concepts, Chrome internally had at least 6 different interpretations internally. So we've done a lot of work to fix those things in Chrome and define, what is a trustworthy, potentially trustworthy URL. And one of the big improvements here has to do with local loopbacks and can you trust them? So you can in Firefox, and now you can in Chromium. And we also have done an experiment in GTK and WPE, which are 2 ports of WebKit that Igalia maintains. And we're opening discussions based on those prototypes with Apple. We've also added extension-specific features because the register protocol handler approaches, one aspect of it, but there are, different concerns when it comes to extensions. And while they're getting more standard, there are differences. So this is a lot better now in Chrome. This list would be really, really long. I'm just going to show you a bunch of links and say that each one of these things represents, a discussion, a pull request, an issue, where in many cases is, a lot there to each one of these links. And this is only a partial list, but each step along the way gets us closer. So there's a lot left to do, right? So I'm going to talk to you about like a couple of things that we're looking forward to doing, challenges that we're looking forward to solving. So one of them is the Chromium architecture. Chromium architecture has these sort of 2 layers, the Chrome layer and the content layer. The Chrome layer is sort of the browser around, and the content is the stuff inside. And they communicate via IPC, and there's different kind of calls in and out. But this creates some real interesting challenges because currently all of the check to find out if something is safe is at one layer, but then the actual handling of the protocol and the registration of it and everything is left at the Chrome layer today. And this creates just a bunch of interesting problems. How it integrates UX permissions and things is not really great for like supporting lots of things in even web platform tests. It raises interesting new questions. In web platform tests, for example, you only are dealing with the content piece, and so you don't even have these. So this is also really problematic for downstream variation. So if you're downstream Chromium and you wanted to support things, everything is currently at the Chromium level. So you have to, you have to bring all of your own stuff for that if you want to have it in the first place, to have it actually work. And then you have to deal with your fork and rebasing and constant breakage and things. So we would like to move this and change where different bits live and allow even the shipping of default handlers at both levels. We think that would be really good, and it would really help with downstream, and we think it could answer a lot of questions for how we would do things with web platform tests to get better universal coverage. So that is what we have been working on and some of the things that we're looking forward to. There are plenty more things, but if you have questions or comments or you want to talk, people from Igalia will be around. You can reach out to me. Thank you.
Thank you, Brian, wherever you are. If you've been hanging out in the Zoom chat here, there are some Igalia folks, and we have been talking about just how fascinating it is, the deep dark corners of the web platform and all the things that need to be fixed, and how any one of those fixes can really impact millions, hundreds of millions of end users, making and now you have millions of developers making their lives easier too, as browsers implementations are more interoperable, more compatible, then developers' jobs, our daily lives become easier. So thanks for that. And there's also a blog post that we'll send out on Twitter too that has a very deep exploration of the fixes and the nature of the work that we're doing. Next, I would like to introduce Tom and Anthony from MetaMask. MetaMask, you may have heard of it before because it is synonymous with many end users' first experience of what Web3 is. So thanks for joining. Let us know what you're up to.
Awesome. Thank you so much for having us, Dietrich, and to the whole Protocol Labs team. We're super excited to be here. So we are going to talk to you about using the MetaMask Filecoin developer preview. I'm Tom Hay. I'm the head of developer relations at Consensus. I work with the MetaMask team very directly. And I also have with me Anthony Albatorio, who is a community builder with all of our decentralized finance products. He's also an instructor with Consensus Academy. So I'll turn it over to Anthony to start just giving you the context.
Excellent. So quickly, what is MetaMask? It's the leading crypto wallet and gateway to Ethereum-based apps. Swap, store, send, sign. It's amazing. It's everything you need to own and manage your own digital assets. So it has all these amazing features for it. And it's available across major platforms. So what is MetaMask Snaps? Well, it's a plugin system for MetaMask. So it essentially goes beyond swapping, storing, sending, and signing, right? It's a plugin system in a script loaded over and verified. It's loaded over and verified over a permissionless protocol like IPFS, ENS, or Swarm. It solves a problem because sometimes plugins can have too many permissions. So these have 0 permissions by default. And then you can extend and work with the wallet APIs. So why have MetaMask Snaps? Well, the whole point of our whole movement is for decentralization and permissionlessness and just more innovation. So we don't want to be a bottleneck in innovation. We also scope the authority. Again, consent is a big thing. We want to avoid the need for excessive authority. So like, let's say a file sharing plugin that doesn't need to know what page you're on, just what things that you want to download. Also, it's more security. So these scripts have 0 privileges by default, but they can request to work with certain APIs, and then you say yes or no. So quick overview again, libp2p, one of the most underrated projects, I think, in the ecosystem. So I think of it as Express.js, but for P2P apps. It's a really mature project. IPFS is built on that. And then Filecoin is built on IPFS, right? So you have a routing system, then you have a routing system that is used for distributed storage of accessing files and websites and applications and data. And then you have Filecoin, which basically incentivizes this accessing of files and websites and data. But then that creates an interesting thing, right? Which is, well, economic incentives lead to assets, and these assets that lead to the need to manage and access them. Sounds like a job for MetaMask, right? So you go, again, swap, store, send, sign, and now more. So a cool idea would be, hey, can you create a dApp that uses Filecoin and Ethereum? You'd be one of the first ones to do so and become a legend. But that's really the context of it, why you would need a snap for Filecoin. So just a quick little overview. So Filecoin beta runs in the Filecoin snap inside of MetaMask. The snap manages the Filecoin keys derived from the seed phrase in MetaMask. So the snap doesn't see the seed phrase or any keys except for those used for Filecoin. At the moment, it doesn't represent the Filecoin transactions or assets in the UI. That's up to the adaptive display to display how those are used. But again, it's permissionless extensibility, so you can fork it and make it better.
All right, so we are not going to try to poke the demo gods today. And so we're going to just walk you through how you would download install and start using the MetaMask Filecoin Developer Preview. So as you can see in this GIF or GIF, fun little debate that we were continuing to have on our check-in today. Yep, stirred the pot. Okay, everyone's awake now. So first, what you're going to do is we suggest that you create a new browser profile. The developer preview is going to work in any Chromium-based browser. It's really built for Chrome or Brave. So the flow is essentially the same, whether it's Chrome or Brave. Go up to your profile in the upper right corner, click on that profile, and then go to other profiles and click add. So create a new one. So that way you have the ability to install a new instance of the MetaMask browser extension without affecting your if you already have MetaMask installed, this won't impact your existing MetaMask browser extension. So then you will download the MetaMask Filecoin Developer Preview. I am going to drop that into the chat. And what you're seeing here is this will be the latest version of the Filecoin Developer Preview. You should use the build for your specific browser. We have Chrome and Brave. If you're using another Chromium-based browser, just use Chrome. If you don't see it listed there. All right, so then you're gonna go into where you type in the web address, Chrome extensions. And then you'll go and click that to turn on your developer mode. This looks the same in Chrome and Brave. You can use Brave instead of Chrome here for that in the URL. Then what you'll do is locate and unzip the package if it hasn't been automatically unzipped, and just understand where that is installed, because you are going to need to use that folder by clicking load unpacked in the browser, and then finding where that file is, and then that will actually install the MetaMask Filecoin Developer Preview. Okay, so then you'll need to set up MetaMask, and we really, really, really recommend that you create a new seed phrase or use a specific seed phrase that you have associated with a development account, rather than using, if you already have MetaMask, then using a seed phrase that's associated with your MetaMask. These should be separate. So what you'll do is you'll come up with a new password, save the 12-word secret recovery phrase, the seed phrase, and secret recovery phrase, just to give you an idea. These are the same. We've sort of changed our terminology. So you might see now, instead of seed phrase, we use secret recovery phrase. And as Anthony pointed out, don't share your seed phrase with anybody. That's why we're using the term secret recovery phrase. Even your development one, don't share that one. Best practices. All right. So once you have that done, there is an existing demo DApp that you can interact with, and I'll paste it here. And you can actually now use that to interact with that DApp and start to sort of look around for inspiration and see what is going on. If you want to inspect the source code, we just pasted it in, and there's a nice little ability to sort of walk through and understand, oh, this is what's happening with the UI, what's happening in the browser. So we highly recommend that you do that. And then there's a super helpful README that just gives an overview of everything put together by MetaMask's Eric Marks. And so definitely recommend that you check that out. We'll be in Discord in Browsers 3000. So if you have any questions about this, you're having any issues, you can always just, ask a question, and Anthony and I will be lurking in that channel and hopefully helping you out. You can also message us in our Discord as well if there's anything that is maybe off topic for this hackathon, but you want to go deeper on. So a little bit of just incentive to use this. If you are best use of MetaMask, winners will receive a seat in the Blockchain Developer Bootcamp. Here's some information about that, so you can see if that's something that's interesting to you or sort of fits the profile that you have. So that is it from us. We'll share the slides so you can check out the flow. But once again, thank you for having us. We're really happy to be here.
Thanks.
Woohoo. Thank you both for joining and sharing. Along with programmable name services, we have programmable wallets. Super excited to see an extensibility vector inside MetaMask. Very cool. And hopefully some people in the hackathon will build some snaps. Thanks for joining. So next we have Julian. We talk a lot in this space and the things that we want to do about unlocking things, unlocking superpowers, unlocking new capabilities, unlocking new features. Julian is going to join us and talk about his project that he started a couple of years ago called Unlock.
Exactly. Thanks for having me, Dietrich. It's a pleasure to be here, and thank you very much for organizing that hackathon. I'm sure you remember the first time we met was at a conference. I was going to say 11 years ago, maybe it's 12, but it's been good to see a lot of the familiar faces in the open web stick around and keep making things better, because we can't really rest on our laurels at this point. Anyway, I'm here to talk about Unlock. Unlock protocol is a protocol for memberships. It's a way to enable creators of all kinds on the web to kind of monetize on their own term by selling basically access to their work, kind of like paywall or features in application or access to their communities. You can monetize, for example, Discord channels. I know a lot of people use Discord. We do use Discord as well. You can monetize tickets to conferences. You can even monetize video streams by just saying, hey, people can only unlock or can only access this video stream if they unlock it. And we'll see in a couple of minutes what that means. I'm going to, like everyone else, play with the demo gods. I hope it's going to work. And so I'm going to share my screen here to check that things is working. I assume you see my screen. I'd love to see a little thumbs up or somebody shouting if it doesn't show up. But this is the Unlock website right now. And the basic example that I'm going to show is basically trying to unlock a website. So I'm on this website. It's at ziplit.online, and it's actually a musician was, I think, in Mexico, was using Unlock to monetize his music. And you can see here that he has a pretty basic HTML5 player, but turns out you can only play 30 seconds of his music. And I'm going to try to kind of mirror the sound. I don't know if that's going to be audible, but basically, since I'm not a member yet, I can only play about 30 seconds of his music here. What's interesting here is obviously that he's added a little button to unlock the rest of the music here. And so I'm going to click that button, and then Unlock is going to show up a little pop-up. He's charging about $1 using XDAI, and XDAI is, I think Makoto mentioned that earlier, it's a sidechain to Ethereum, so that is compatible with the Ethereum ecosystem, and you'll see that I'm using my crypto wallet MetaMask here, just from the previous demo, and I'm just going to select that one, saying, hey, I want to do this. Here I'm going to actually show you the example, not with credit card, even though this is a feature that we have, but using my crypto wallet. So I'm going to connect my crypto wallet. I'm going to select my in-browser wallet. We also support Wallet Connect, which I think somebody mentioned earlier, which is a mechanism for people to use a mobile device to connect their wallet. And here I'm going to just check out with my wallet. So MetaMask is going to pop up. Hopefully, yes, MetaMask is popping up, saying, hey, do you want to pay about $1? I'm going to say yes, $1 and 0.0085 cents worth of gas, which is the transaction fees that you pay on the Ethereum chain. I'm going to click confirm here, and boom, immediately you see that the page has been unlocked. I can now enjoy my membership. I'm going to just close that. And you see now that there's this little gimmicky application that basically the CD, and for the youngest people, that's actually how we used to listen to music in the 90s. The CD kind of starts to rotate. And more importantly, I can now play up to 4 minutes of the music. And so again, clicking play here, again, an HTML5 player, and it's all available here for me to listen to. Cool. So that was the unlock demo. What I didn't tell you yet, which I think is a buzzword these days, is the word NFT. In practice, the membership that I've unlocked here is an NFT. Technically, I've purchased an NFT from that, Miguel is his name, a musician, and I'm going to show you that this NFT is now in my wallet. So at Unlock, we also built what we call the keychain, which is, and again, this is bigger here because I'm sharing my screen. Normally, it doesn't look as big. It's a little website, a web app that basically reads from the chain to assess what are the things that are in my wallet. So you see that I've got a bunch of memberships, and one of them hopefully is here. Yep, that's the one here. It's called void2.mp3. That's how we call this membership. And it's valid for 23 hours, 59 minutes, and some seconds because I just bought it. And that is an NFT. That's the NFT number 4 on his smart contract. What's interesting about the NFT, obviously, is that I can transfer that to somebody else. I could maybe lend it to somebody else as well. And if I did this, I would not be able to listen to the music anymore because I wouldn't have the membership in my wallet anymore. But the person to whom I would have transferred it would be able to listen to the music. So I hope that makes sense. This is a very high level demo of what Unlock allows you to do. People have used Unlock to kind of provide access to some private channels on Discord, as I said earlier. We have a very exciting plugin that's coming very soon around Shopify that allows people to unlock, basically discounts and, free shipping. I always joke, but I think it's the case. The biggest membership of all in the US is Amazon Prime. And so you can build Amazon Prime membership on top of an open protocol called Unlock, which is pretty exciting. Another thing that people have done about a year and a half ago, Forbes.com, which is a pretty big website, you might have heard of it, used Unlock to offer an ad-free experience. So if you had their NFT in your wallet, you would see no ads on the Forbes.com website, which is pretty exciting. As I said, people are doing kind of unlocking of videos, of blog posts, of forums. You name it, basically. There's an endless suite of things. One thing that I'm very excited about is the idea of using Unlock as a way to do software licenses. We talked about pinning services earlier. I think one cool approach would be say, hey, the pinning service can charge with credit card. And by the way, we actually have a way to charge with credit card as well. Maybe I'll show that in a later demo another day. But basically that pinning service could say, hey, you know what, we'll allow people to pin data on our server only if they have the NFT in our wallet. And what this unlocks, pun intended, is the ability to work with, for example, DAOs in the Ethereum space. But I think beyond that, at this point, people start to realize that one of the core innovation of crypto networks is the idea of these DAOs, this decentralized autonomous organization. The challenge with these is even though they have money, a lot of money these days, they actually don't have an easy way to spend it because a lot of the SaaS services that we all use and love online basically require credit cards. And these communities obviously don't have a credit card account. They have a multi-sig wallet. They have ways to pay with cryptocurrencies, but all of these SaaS services that just require credit card basically are leaving them out. So one idea that I think would be really interesting for the hackathon would be to build kind of a way to pin data. And Mauve's demo earlier was kind of really cool to pin data in a way that doesn't require me to pay with a credit card, but allow me to basically prove that I have an NFT in my wallet. And in that situation, the data gets pinned. So I think that's a pretty cool example of thing that can be built. Maybe the next step, I'm going to show you how to actually deploy your own membership. So again, we have a little app, and again, it's bigger, called the dashboard, where people can do that. I'm going to switch to a test network. So on Ethereum, there's several test networks. I'm going to use Rinkeby, which is one of the most popular ones. And I'm going to authenticate with my wallet here, and you'll see that it's basically going to load a bunch of my different locks. And I've got a lock that was deployed on the 6th, which was 2 days ago. A lock for my friend Jess, a block from June 28th. So all of these are memberships, and I'm going to create one now, and you'll see that basically I need to put a name. So let's do a membership for Brother 3000. I think that's a cool name. It's going to be valid. You know what? Let's do 60 days. So it's valid for the duration of the whole hackathon, and we're going to limit the number of members to say 500, which would be the number of maximum participants that we get. And this time we'll say it's free. So there's no need to charge for that because we don't necessarily want to make money out of this, but we just want to have a way to identify our members and maybe put that on the Discord server or something like this. I'm going to hit submit here. My crypto wallet is going to pop up, and same, it's MetaMask here. So it's going to pop up, say, hey, do you want to pay that much in gas? And just say yes. This lock is now going to be deployed. What's now really interesting about this is it has, for example, a little image that I'm going to customize here. Again, looks a bit bigger because I wanted to make sure that everybody can see. Normally it's not as big, but I'm going to upload a file. And obviously, you pre-guessed it, I'm going to use the logo of the Browser 3000 hackathon. And so I did a very cheap screen capture earlier. And I'm going to have to make it a bit smaller because I can't even see the submit button, but I'm going to save this. What's interesting here is like we're using MetaMask to sign a transaction to make sure, another transaction, sorry, sign an API call to make sure that I actually own that lock. So I'm setting up the image that's going to be used on all of the NFTs. I'm going to sign here, and boom, you can see now that the lock image has been replaced. And what's really cool now is we have a little demo phase. Actually, let me show you something else. We have this integration pane that allows you to see what are the multiple ways the lock can be integrated. So we have a WordPress plugin, which would mean that if we wanted to publish content on WordPress sites, we could easily add this, and only the members of Browser 3000 could be able to attend this. I mentioned Discord. We have a Cloudflare. I know the Cloudflare team is here. We have a Cloudflare worker that could be used to allow people to, restrict access to their websites only to the people that have the right NFT in their wallet. Actually, I think now Cloudflare has apps, so it would be cool to see if somebody would be interested in hacking on this. We have an integration with Webflow, which is this no-code kind of site builder, pretty cool. Integration with Discourse, which is the forum software. And really, we have a lot more coming. And if you are interested in building integration, you should definitely reach out to us. We also have a few tutorials to build kind of custom experiences. So we have a way to kind of remove ads on the website if somebody has the membership in their wallet. We have a way to sell tickets to a conference. And so maybe that's something that you want to use here. We have a way to get donations on GitHub. Actually, let me show you this. This is pretty cool. All of Unlock is open source, everything from, the smart contract, obviously, to the front end code. And one thing that we have, which is pretty cool, is like we have a donation button here that actually uses Unlock. So I'm not going to show you this, but what we have here at the bottom is a way to show all of the icons of all of the people that support Unlock. So if somebody if somebody purchased an Unlock membership right now, and it's actually free, so that would be easy, their icon would be added to that list in real time, which I think is pretty cool because this is an SVG image that is dynamically generated as the page loads. So it's pretty cool. Let's go back to the dashboard here. We can also create a Substack-like experience, like a newsletter, and that's something that we provide. Obviously, we have pretty extensive documentation, and that's one of the links that I'll post in the channel, where you can find all of the information about how to use Unlock, creating a lock, which is the thing that I just did. You can enable credit card. I didn't show you this, but that's actually pretty straightforward. And in that scenario, even people who don't have a crypto wallet can purchase your memberships and have an NFT in their wallet. I invite you to look at the docs here. It's pretty interesting. You can customize the NFT, which is what I did with you, a list of custom plugins and integration. And then we have, maybe for you, a list of kind of pretty extensive documentation around how to use Unlock. And so these are all of the components that we provide to the smart contracts, Unlock.js, which is a JavaScript library, Subgraphs, which is a way to query the locks data in real time as well, which is pretty cool. A way to kind of set metadata on NFTs. The paywall application, which is kind of a more advanced JavaScript integration to our site, and Locksmith, which is kind of our backend server, where we can do a bunch of interesting things like create user accounts and charge for credit cards and things like this. Going back to the dashboard now, I'm going to finish my very rough demo. I'm going to click on this fake, basically paywall site, which is going to use the membership that we just deployed a couple of minutes ago. I'm going to click join us, and obviously same as before on the musician's website, I'm being prompted to purchase a membership. It is free. I'm going to just connect here, connect my crypto wallet, and you see here, obviously I've not enabled credit card. Connect my crypto wallet in browser wallets, same as earlier. This time I only have the option to pay with my wallet, and I'm going to do that right away. And what's interesting, you see that now the rest of the content is immediately visible. And by the time, so what we do, one thing that you might wonder is like, how come this is immediately unlocked? We do what we call optimistic unlocking, where we look at the transaction itself and assess how likely it is to go through. We don't require users to wait for this because sometimes block time can be slow. But here it's been mined, and you can see here on Etherscan, which is a block explorer. Etherscan is slower than MetaMask to identify that it's been mined. You see that I actually have now minted an ERC721 NFT, the token ID number 1. Obviously, that's mine, and it's called Browser 3000 here. And maybe I'll do something even crazier. I don't know if it's going to work, but like you probably know of test of OpenSea, and so we have this thing on OpenSea where I'm not sure it's going to work, but let's try. Where you can actually view NFTs. Yeah, they work. Pretty cool. So it's going to load the data. Oh, it didn't include the image that I just said, so I'm not sure why. Let's refresh it maybe. But that's the NFT that I just bought. It's now on OpenSea, and I can transfer it to somebody else. I can put it up for sale. I wouldn't do that because it's free. But you know, if I had a paid one, I could definitely charge for this. So yeah, basically documentation, I invite you to kind of check that out. Our website, which is here. Oh, actually prices. We definitely are excited about you building on top of Unlock. So we've added a couple prices. You can get some of our governance token. And basically these are tokens that allow you to vote on the upgrades of the protocol, on how it's going to, you know, be governed in the future. So we definitely invite you to win this, because I think it's actually a pretty cool prize. We also have stickers, and maybe by the time this is over, we'll have hoodies and t-shirts. So please come build amazing things. Join us on our Discord. And by the way, you're going to have to unlock it, which is pretty cool. You're going to use Unlock for this. Follow us on Twitter, and please do reach out to any of us. I think that's pretty much it for now. Again, pretty excited to see what you all can build. And if you're looking for ideas, please come check with us on Discord. We have a ton of stuff that we'd love people to build, and we'd love to help you do that. All right.
I didn't know about a whole bunch of those integrations. Very, very cool. Next time we'll just run the whole hackathon on Unlock.
Let's do this. I'm looking forward to that.
And
yes.
Also, it's very, very gratifying to see all of these demos of working software. These are all things, I guess, you know, we kind of planned this event talking about the future, but we're talking about the now. These are things that you can do in browsers today and with APIs today. A lot of this, we're going to see, I guess, all that stuff just getting better and easier and better and easier. So thanks for joining and demoing for us. Next, we have, all right, so this wasn't intended to be a conference of people that I knew for 10 years or more, but next we have Daniel from Microsoft, who'll be talking about ION and the work that they're doing in decentralization, somebody who I've known from way, way back. Welcome.
Hey, thank you. Can you all hear me?
Yep.
Okay, great. Let me just share the correct screen and I will get started. Yeah, as Dietrich noted, you know, I've known him and worked a little bit with him since days at Mozilla, when I think that, you know, we all shared the same aspirations in terms of having a web that stayed free and open and decentralized. So I'm glad that, you know, he's in this ecosystem and working alongside folks like yourselves. So let's dig in. If everyone can see the screen, I'm going to talk a little bit about ION. This is decentralized identifier network that we built, collaborated with others to build, actually, not at Microsoft, at Decentralized Identity Foundation, but we were major contributors. Let's dig in. So understanding the problem, first thing to understand about decentralized identifiers is like, what's the actual issue that they're trying to solve? You know, we don't just want technology for technology's sake. Two types of identity data will help sort of focus on the issue of decentralized identifiers. There's your identity data, which is all the stuff about you, right? Like your, you know, credentials, your tweets, your blog posts, your photos, all that stuff's identity data. Describes you in some way, it's an expression of yourself. And then you have identifiers, which are the actual references to your identities. And you might have multiple sort of facets of your identity, like personas, as it were. And those identifiers today are typically email addresses, usernames, those sorts of things. And they're owned by companies. So there's some issues with that, right? The status quo of identity, your identifiers can be snapped out of existence, right? It can just be dusted anytime a provider wants. Your connections go with that. So if you have, you know, your ID severed, email address or a username in an app, you know, like Twitter or something like that, all the connections and followers and all the stuff you built, the relationships you built over time, while they may not go away with the people, it can make it much harder to connect if you lose, you know, that reference, because sometimes people speak over pseudonyms, which means that they might not know exactly how to contact you again. And your content can be deleted in a keystroke. So it's really important that we get this right, because we're seeing this more and more in the world today, where the answer seems to be, because we've commingled identity, is that we sever people from what's increasingly becoming more important, which is your digital persona. So this isn't hypothetical, and I know you've all seen it. Tons of people are getting, severed from Twitter, which, deletes all their contacts and everything else. And that's just really not acceptable. Interestingly enough, in the time since I gave this talk with this one slide that happened to be in it that I presented before, I was actually suspended from Twitter for 12 hours. So I got a little taste of it, even though I've talked about it for a long time. And I've seen, friends who are very much mainstream get suspended. And I'm sure you all know folks. It's shitty to have happen to you, and you don't want that to be the case. And it's all because we've commingled identity with apps because we don't have a digital identity layer for the web. So apps become this sort of de facto identity, which is really not how things should be. So how do we fix this? Well, we have this really cool new spec that's just about finished. It's going to be an international standard here in a matter of months, called W3C decentralized identifiers. It's codified in the same body that codifies web technologies and browser standards, the kind that Dietrich and I used to work on at Mozilla. So it's a robust standard. It's been worked on for many, many years, over half a decade, and finally, arriving. And essentially what it is the ability to give you identifiers that are yours, that are truly owned and controlled by you. It defines a data model and a URI scheme, which you can see over there on the right of my screen. The URI scheme is basically did : like you would have HTTP : that's where IPFS : that sort of thing. Then you've got your method portion. The important piece there, you see ION, is that there's not just, ION isn't the only type of decentralized identifier that could adhere to the spec. There could be other constructions as well, but ION's one of them. And that's what that segment means. And then the other gobbledygook on the right side is the actual identifier itself. And these identifiers are backed with cryptographic keys, and they also can include things like routing endpoints. So it's not about identity data. That's the one big thing I want to, like we talked about in the first slide, there's your identity data, there's your identifiers. ION is not a system of putting your identity data somewhere public. It is a system of identifiers. So it's how do you prove you own this string? And then what are the routing endpoints that I could go to find data, in a private data or communicate with you? So what's the real core like technical issue, and why aren't DIDs, like why haven't they been around for a long time? Well, there's actually like this really, really interesting problem that's been around for 40 years, ever really since the dawn of like digital identity itself, and the CA system, which is you don't really have the ability to know what keys are related to an identifier, what certificates, in the traditional system are related to an identifier, like a domain, in a decentralized way. So we've had to create these hierarchies. And the reason why is because, as we see here in the example of the identifier of Theseus, there's never been a system of record that keeps track of historical change, linear historical change, that's decentralized and immutable. We've never had that before, right? And that's actually what Satoshi solved with Bitcoin, was creating this thing. Up to that point, we had CA systems that were based on hierarchies and central authorities, and someone saying, well, this domain name's associated with this set of cryptographic material because I say so, right? And you don't have to know the history. It's just whenever I say it's different, it's different. Not a great thing for basing like human identity on, because that's a human rights risk, in my opinion. So what we see here in this example of Theseus is when an ID starts out, it can have one set of keys and one set of endpoints with it, right? And Theseus is this Greek hero. He left on a journey with the ship. And over the course of his journey, everything about the ship's changed. So like every nail and board, everything about it. So it looks very different. So over the course of time, you're rotating keys, you're switching out endpoints. And then, far down the track, nothing about your DID or its lineage, its secure lineage is the same, right? So we haven't had that ability to track that. So in this case, in this example, when Theseus' ship comes back to the dock, if you imagine someone who saw it when it left, they would question, they would say, well, is this Theseus' ship? I don't know. I can't securely understand or know because I wasn't there when every board and plank was replaced. So that's what you need for PKI. You need something that can track the backbone of key lineage and what routing points are supposed to be associated at any given time. So let's talk a little bit about ION and how it might solve this. It's an open, public, and permissionless layer 2 network that runs atop Bitcoin, provides robust decentralization, interdiction resistance, and scale. So we can do DIDs at scale right on top of Bitcoin. Unlike other DID protocols, it doesn't rely on any trusted validators. There's no centralized authorities, not even Microsoft. We don't have any like authority in the system. It's a mathematical protocol. No additional consensus schemes and no special utility tokens. We didn't want any of these things when we built it because we wanted it to be completely a public utility and controlled by users. What is it at 10,000 feet? And this is where we start getting into the IPFS portion of this. So if you look at this sort of layout here, you've got a couple different ion nodes. If we assume there's only 2 ion nodes in the world, this is kind of how it would look. First ion node could batch one or multiple operations, so creates of IDs, updates of keys, that sort of thing, together. And this could be anyone. This could be Alice at her house. This could be like Microsoft running a node, whatever. The only point of aggregation here is that some people might not want to be running Bitcoin or doing cryptocurrency transactions or paying, so you can aggregate them. People can do this for you. All the operations are signed before they leave your device. So if I, as Alice, wanted to have Microsoft anchor one of these operations for me, it's not like they can mutate it. They can't do anything insecure. They can't violate any part of the operation itself because it's cryptographically secured on the device. Once those are assembled by Ion Node 1 into a batch, they're anchored into Bitcoin with an IPFS CID. So what Ion Node 1 did was it sort of assembled this file structure, a few different files, and then it put it together through some linkages and anchored that in a CID in Bitcoin. And what all the other nodes are doing is they're all watching Bitcoin. So when they first start up, they're like going to the block number, that's the starting number for Ion, and they're essentially reading forward, and then they continue observing, and they're looking for these CID, these marked transactions in Bitcoin. And when they find them, they fetch the data and then circulate it through the IPFS and underlying libp2p protocols, and get it and process it all the same. So it's a deterministic system. There's no agreement between the ion nodes. There's no secondary consensus. It is purely data and determinism. So what do the file structures look like? This is basically what those ion nodes do when they're creating operations and bundling them together. They are essentially creating a tree of files that serve different purposes. You can see them here. I won't go into all of them, but they're all IPFS files. They're all linked together, and there's a root CID that's put into the blockchain. I'll note that Brave and Opera already integrated IPFS, as you probably already know, and other browsers that I can't name specifically on this call, but I know very well, are also exploring integration as well. So what Ion delivers, massive scale, right? We can do thousands of PKI operations a second, tens of billions operations annually. We can support the entire globe if we needed to, just on Ion. Cost efficiency, even people ask, well, what about the fees? And I say, even at $100 per Bitcoin transaction, we can do a PKI operation for as little as 1 cent an op. So what an operation is like, they're very infrequent. It's like if you were to get a new phone, you need to rotate from a old phone to a new phone, you need to associate the key with your ID. So that's, 1 cent, pretty cheap, right? They probably charge you more for the SIM card inside your plan. Decentralization, it's actually decentralized, unlike some other protocols out there that you might, see. There's no like rug pull, smart contract, master key. There's none of that stuff. Ion nodes are lightweight. They can run on Raspberry Pis. They're not bottlenecked on CPU. It doesn't take you a long time to start up a node. It's mostly storage. The system is a lot IPFS, a little bit Bitcoin, and then some processing logic. So it's an intrinsic utility consumer. Ion consumes the most intrinsic utility of Bitcoin, which is just the actual transaction space. It doesn't need a whole lot. For about 100 transactions, we could support the globe with 50 billion DA ops per year. So what are we using this thing for? Right off the bat, verifiable credentials, and then later on, probably personal data stores. I'll just kind of go into it. The foundation of verifiable credentials is the ability to sign a proof from someone to someone else, right? In this case, we've got Woodgrove, an issuer of an employment credential, for instance, and they're going to sign this credential to their employees. Their employee can go anywhere they want and prove that they are, in fact, an employee of this place. Ion, in this case, is just used to look up the public keys behind the IDs and do the signing, right? And so it's really there for that PKI substrate. Another one that we're working on, Dietrich, is, we talk to a lot of the groups frequently, groups like Textile and Fission and Ceramic, is personal data stores. So when I talked earlier about DIDs can have associated with them routing endpoints, well, to where, right? What are those routing endpoints to? We think in the future it's going to be these personal data stores. And if you know someone's ID, you can look up their routing endpoint and you can send messages and you exchange other pieces of data with them. A couple of use cases I'll quickly go over. Hey, like Signal and Telegram are awesome, right? But wouldn't it be better if we just had, a standard encrypted messaging layer for the web? I think it would be. And that's exactly what DIDs plus personal data stores are. If you know someone's ID, you can encrypt a message by looking up their keys, send them the message to their data store. And now there's a substrate that's common. So you could build apps like Signal and Telegram and others on a common infrastructure that's standardized, where the app itself is mostly just UI and sort of some affordances you build around it. But the underlying layer isn't like a per app sort of infrastructure, and it's much harder to block in places that want to like suppress communication. Another one that we're doing right now is, the ability to go to an ID and fetch some data that proves maybe what it is. So in this case, a school, right? Do you know if it's accredited? Well, if you find the DID of the school and you want to go to those endpoints and go to its data store and say, hey, give me this accreditation credential, right? That's one way that we're going to be using these things right off the bat. And last one I'll go through is, travel plans, right? Like, isn't it amazing how like all your apps have to do this thing where they all store data in silos and then someone has to try and make sense of this. If your data is stored with you in accordance with your DID in your data store, you can grant access to apps and they can sort of work off the same corpus of data so that you can have an app that shows a visualization across all of these different activities, which is a huge benefit to the user. So I don't know if I have a little bit of time, but I was going to show like an actual live kind of demo here. If you wanted to get involved with Ion as a developer, we've got this library that I helped write, which is just a JS library that works in the browser and in Node, and essentially gives you a really easy way to create Ion DIDs. And that's like right here. This is creating an Ion DID. You get your first DID. You can use it right away. There's some other helper methods here, like generating the URI for the DID, things like signing, like generating key pairs for the various supported key types, JWS verification signatures, and a few other things. And you can even anchor the IDs and resolve them. The default is our Microsoft server because we're running a node that resolves and anchors. So we're covering the cost of the Bitcoin anchoring right now. And we're doing the resolution, and that's fine. You could put your own endpoint in if you want, like if you run your own Ion node, but we're just doing this as a help to the community so people can get started as quickly as possible. And just to show you it's not BS, here's me creating a bunch of Ion DIDs. You can see here, we're just running through them. And I might like say, I'm going to put this JWS and test it out. And, it's basically generating JWS, it's signing it, and then verifying that, in fact, the word test was signed over by the DID that's been created down here. So you have all these capabilities in a library that's very easy to use in the browser. And that's basically Ion in a nutshell. We'd love, your support and, get involved. It's all done through Decentralized Identity Foundation. So decentralized identity or identity.foundation/Ion at the bottom of the screen. There's an install guide there. You can run it bare metal or Docker, and the links to the JS library. Great. Cool. That's all I had. So turn it over to you if there's any questions, or off to the next presenter.
Thank you so much for coming and speaking with us, Daniel. One of the things, in the last couple of years and where we are now, that all these technologies, we're using these as superpowers, we are building these projects in the vision that we have. But the benefit that the web brings us is the fact that it can work interoperably and compatibly for everybody. And so I really want to applaud the efforts that Daniel has been doing in the IPFS and identity communities around helping to forge an interoperability layer. So some of the early efforts in figuring out how in this next version of the web that we have things like account portability or data portability are really going to be important. So looking forward, maybe not full standardization yet, but the idea that we have interoperable and common patterns, and that's really emerging out of this work in the identity hubs space. Very exciting to see. So thanks very much for coming and sharing with us. Also dropping some hints about things to come. Next, I want to welcome Thibault from Cloudflare. Cloudflare is one of the first folks that stood up a high volume production level IPFS HTTP gateway, really easing the way for people to get data from the IPFS network and be able to use it easily within their applications. And we've been working with them for a long time. So we're excited to have Thibaut here today to talk more about what Cloudflare is doing in the decentralized web.
Thank you, Dietrich, for the introduction. So hi, everyone. I'm Thibaut. I'm a research engineer at Cloudflare. And today I'm going to present how you can leverage Cloudflare to browse the dweb and to host your application like more easily and make it more accessible. So first of all, who am I? Quick, who am I? So I'm a research engineer at Cloudflare, working on like various projects, but like most of all on distributed web projects such as IPFS and Ethereum. Gateways, HTTP gateway that we're operating. I like croissant, so if you meet at some point, like definitely feel free to catch one. Of course, like for now, it's like the situation is like a bit more virtual, so definitely like feel free to take like a virtual croissant and a virtual coffee as we go through the presentation. What we're going to talk about today is, first of all, have like a quick demo of what system Cloudflare has at the moment to offer on the HTTP interface, and then how you can use Cloudflare to browse the dweb, and more specifically IPFS. So first of all, before we dive in, Cloudflare has been operating, I think as Dietrich mentioned, like IPFS gateway for like the last 3 years. We operate both a public gateway that everyone can like access and also provide X509 certificate, which are like so-called SSL certificates for every internet properties and website that are like hosted on IPFS. And so that allows these domain and these internet properties to serve their content to customer in a secure way and in an interoperable way with the current web ecosystem. Over time, we have run multiple experiments over the network. So like this include like providing verifiable responses for IPFS gateway via an extension. We also operate like a subdomain gateway for quite some time and have increased our peering over time to provide better content and faster resolution for content hosted on IPFS. Finally, we are like, I think like as of now, one of the heaviest users of the IPFS network and definitely looking for experimenting and like gathering like more provide a better service to everyone using it and leverage the network that we have already. So in terms of the demo, it won't be like an interactive demo, but definitely if you want to go, I will like go through steps and share the link with you so you can like reproduce more easily. And what we're going to do is we're going to like onboard a domain for like T-Book Corporation, like big corporation that has just started, not registered yet. And T-Book Corporation, they want to host their domain, which is ipfs.co.uk on IPFS, and use Cloudflare to serve it. So it's like served in every edge location, like served through like a secure TLS connection. To do that, we're going to like leverage multiple services. So of course, Cloudflare IPFS. We're also going to leverage Cloudflare DNS to provide like an easy recognizable name, which the brand already has, which is IPFS.UK. And then finally, we're going to use an external provider to pin our content on the IPFS network, and we're going to use Pinata for that. In the end, we're just going to configure the domain, use an IPFS client with remote pinning capability, and now that's like supported on most IPFS clients, thanks to work done recently on Collab, and use a web browser to like browse the web. So first of all, you want to publish your content to IPFS, and like that's done like technically 3 lines, but the first line is like to generate the content. So I want to generate a page for the home page. So this could be like either like here a static homepage, but definitely you can leverage build systems to output some content. So we're going to like output that in an index.html. We're going to start the IPFS daemon so we can have the content available to the IPFS network. And finally, we'll add the content to IPFS. So from that point, we like our content is like served through IPFS. To go through So steps, I will share like this link later on where you have all the steps in the command I display here. Then you want to pin your content to a public pinning service. So like this is meant at two things. So content can stay available and being served even when your computer is offline, because we were running the IPFS daemon, but we want to pin it. You can pin it to one service or multiple services, which provide like more reliability to the content. Here I'm going to use Pinata. So I use like Pinata API with a JWT, and I have a CID, which is a CID of the content I just added before. Then I remote, I want to pin the service using the IPFS client. So you use IPFS pin and you pin the content that you have. So that identified by the CID, and you pin it to Pinata, and then it's available. So even if I turn off my computer, I can still access the content through Cloudflare IPFS gateway at cloudflareipfs.com/IPFS/CID, which, I mean, it's great. Definitely that's good, but like I don't want my customer to access the content through cloudflareipfs.com/IPFS/CID, which is like quite terrible to look at. And so we want to add IPFS.tw.uk as a source for the content. And so that's where the Cloudflare comes in. And we have two steps of configuration. So the first step for the configuration to take place is we need to add like on the DNS name, a CNAME for IPFS record for the IPFS subdomain, and we will point it to cloudflareipfs.com. This way, all the content going to IPFS.tw.uk will go actually to cloudflareipfs.com, and the gateway will be able to serve the content. The second thing is a protocol which is called DNS Link, which has been pushed by IPFS and like very well integrated. And so that allows you to specify the content you want to serve within DNS and within a DNS text record. So by creating an _DNS linked.ipfs record on tw.uk, I will be able to add the content that this domain points to. And so when the request going to the IPFS gateway will land in, the IPFS gateway will be able to know the content it needs to serve for that domain, looking at the DNS record. This is very similar to what Makoto mentioned earlier on with the content hash, except this time it like embeds within DNS. Then the next thing you would like to do is to have a TLS certificate, and you do that by going to cloudflareipfs.com, and just at the bottom, you will be able to submit your domain. And by clicking submit, we'll provision a certificate for you. And so every time a customer will access ipfs.tw.uk, it will be made through TLS connection. And so we have like the little famous green log that will appear on the top of your search bar. Of course, there are like a few commands you can run to make sure that like your domain is properly configured. And this is regardless if using Cloudflare or any other gateway. So you need to be sure that like your domain will be served through a gateway. So in our case, we configured through Cloudflare. So you just run this this D command to make sure like that's configured. And finally, you also want to make sure you have the DNS link configured. So you do like another lookup for the text record, and you will see the contents properly configured here. So now that you have some content hosted on IPFS, you may want to browse the dweb a bit deeper. And actually, there's like a lot of ways to do that. And that's what I call the original trilogy, because like mostly there's 3 ways through HTTP to browse the dweb. And those 3 ways for HTTP, there are like 3 independent ways, independent gateway. Usually the most popular, the thing you will see the most would be like for Cloudflare at least, would be with cloudflareipfs.com, which is a PaaS gateway. And definitely that would be the most visible usage of Cloudflare if you navigate the web, because you will see cloudflareipfs.com everywhere. Does that present as like cloudflareipfs.com/IPFS or IPNS, depending if it's a domain with CID, / the CID of the content. So that's great because like it clearly makes a distinction between like who's serving it and which content you're serving then. The thing is, the way web browsers are designed as of now, you will not benefit from same origin policy and isolation. So definitely while this is like a great and easy way, this is probably not the way you would like to browse the dweb. The way we presented just before is using example.com directly with the domain configured with DNS link and pointing directly to a gateway. It's definitely like the most flexible way to access the gateway, because you could point it to Cloudflare the gateway to like another gateway as well. While you have something very transparent, you have the domain which is provided directly, and so it presents as example.com directly. You have your own same origin policy. The only thing you won't have with this is like you won't be able to configure all the policy you want if you're passing through a gateway. So that's also to be considered. Finally, one thing that has been pushed like recently, and like there's a lot more effort going on that way because it's definitely more secure, is using a subdomain gateway. So like as of now, like it's cfipfs.com or dweb.link, for instance, for Protocol Lab. This is like something that has like still low usage, but it's very neat in a way that you're able to have like example.com embedded just below a domain. So it's like a distinct domain and a domain of its own. And so that allows you to have same origin policy and isolation, which is very great. And that's something which is integrated in like web browsers. Both like Brave and Opera are for now like using this way for resolving content, which makes it like far more secure. And so then on like web security, when you're like going through using HTTP gateways, definitely providing like an X509 certificate for users is important. You don't want like your, when browsing, having like an HTTP connection only. You want to like leverage what has been done on the security of the web, even so it's not the same protocol as IPFS. For like convenience, having X509 certificates is like rather important. It may not be compatible with all the name resolution service, especially with new name systems. And so that's definitely why, for instance, when we operate east.link, we really wanted to make sure that we provided X509 certificate for all the domain that are on the .east domain. Also, something to keep in mind is the course rule for the gateway are usually very loose and are set by the gateway, not content owner. And because we have to serve the content for various users, like these rules are for now like rather loose. And usually like we have access origin allow for everything. Definitely if you want something more tight, that's something you can contact us or contact like the gateway provider to adjust. Finally, IPFS provides immutable content that can be accessed like via the CID, but that doesn't mean that like sometimes the request of the CIDs that you will ask for may not be accessible. It may like time out because your node is not well connected. It may time out because like the content is actually has never been stored on IPFS. And one feature which is like super great, which has been like added over last year, is to provide custom for pages. And so that really allows you to have more flexibility on like how you want your website to be displayed. So that's probably something you may want to leverage with the hackathon. Finally, some closing words. Is what we've seen, the usage of IPFS is like growing really fast. And one of the hardest thing to do on IPFS is like leveraging names. IPFS is immutable content, but when you want to make this content readable and accessible, you need to leverage names, and it's something which is like rather hard to do. And definitely there's a lot of ways that I invite you to explore through the next 6 weeks. In the end, IPFS and IPNS and like more protocol, as like a lot of speakers before presented, are getting integrated in browsers, and that's definitely like something which is awesome because it provides local availability and more resilience. At the same time, Cloudflare is like here to help still get the bridge between IPFS and like the regular HTTP interface. Thank you for listening to me, and if you have questions, just like don't hesitate to contact us through like either Discord or directly on cloudflareipfs.com.
Thanks, Thibault, for joining, walking us through what Cloudflare is doing. Just so exciting to have you share that IPFS usage is growing fast from your perspective. And that means that it's ever more important to have high availability and high volume services available for people that are publishing content onto IPFS. And easing access to that data until we get all of the browsers integrated with IPFS is super, super important. HTTP is going to be the air we breathe for quite a long time, even as usage of these other protocols are growing. So it's great to have a partner like you making sure that these things are available. So next we have, well, so far we've been talking with a lot of people that I've either known or known of. It's also great to meet, for some time, to meet some new friends. I'd like to welcome Fission from Handshake, who will be telling us about Handshake protocol and what you can do with it.
Awesome. Cool. Can everyone hear me?
We can.
Okay, cool. So yeah, today I'm going to talk about Handshake. I'll share what it is and why you might care about it, what you can do with it, and show off a demo or two on what's possible. And for those who aren't familiar, Handshake is a decentralized naming protocol. It's actually specifically meant for decentralized DNS. So, similar to a lot of other naming protocols that have been discussed today. But one thing that's pretty interesting about Handshake is it's really focused on DNS and specifically root naming. So for example, if you take a website like google.com, the root TLD of that domain name .com is the basically the parent of every domain name under .com. And the way that DNS currently works today is that there is an organization called ICANN, which basically governs who gets what TLD. And then each TLD individually is owned by a different entity. So for example, VeriSign owns .com, they're a for-profit public company worth billions of dollars, and they make a lot of money selling .com domains. .org is owned by another organization. And then, you have some TLDs like .ai, which is owned by a government basically, and not a single, company or nonprofit organization. And the way that new TLDs get registered today is, well, right now it's not actually possible to register new TLDs, but when ICANN allows new TLDs to get registered, there's an application process. It costs $200,000 minimum. And again, it's all organized under this existing kind of centralized system that was the only architecture available at the time that DNS was created. But now with blockchain technologies, we have new architecture available. And Handshake capitalizes on that and has created a decentralized naming protocol that basically allows anyone to register their own TLD. And the interesting thing about it is the adoption is, of course, still very early, but it's already gotten integrations with a number of traditional domain registrars that you probably have heard of, like 101domain.com, Encirca.com, and epic.com. And already actually Namecheap has been recently getting into Handshake, and they purchased a Handshake name for $250,000. So they're kind of investing heavily into it. So that's what Handshake is at a nutshell. And I'm just going to show off real quick what you can do with it, because it's interesting. If you think about it just at the surface level, it's just for decentralized TLDs. But really what Handshake does is it basically just puts a root name on the blockchain and allows you to associate arbitrary data with it that's cryptographically secure, through a mechanism that works very similarly to how Bitcoin works. And you can use that for a number of different use cases. You can use that, even outside of like a TLD. Normally, you can use it for a personal website. You can even use it as a decentralized username. And I'll just show that off right now. If I can share my screen. Here we go. And so this is Namebase, which is the company that I run. I'm the CEO of Namebase, and it's basically an easy way to use Handshake if you've never used it before. And you'll notice in the bottom left here, it says connected to Handshake DNS. So we run a DNS resolver for Handshake that makes it easy to connect to it and use Handshake as your root DNS. So what I mean by that is if I go to Nick Carter / it'll resolve to Nick Carter's personal website, which is, we call this a D-Link. It's basically like a little link tree alternative using Handshake names. And some of you might be familiar with Nick Carter. He's a pretty popular crypto Twitter personality. And so he has set up his own website at his Nick Carter TLD right there. And the interesting thing about that is that you can actually just type in Nick Carter / in your browser when you're connected to Handshake DNS, like I mentioned, and it'll just resolve. And of course, you can also use a name, a TLD like a normal TLD where you have a subdomain at it. So right here, I'm going to welcome.nb. NB is a TLD that we own on Handshake, and then we set up this subdomain to resolve to this little static website right here. And then if you're not connected to Handshake, which by the way is very easy to do, in order to connect, all you just gotta do is go to your network settings, and then you just go and change your DNS resolvers to add these two numbers right here, and then you'll be connected. But that makes it difficult to share your name on the internet, because if other people aren't connected to it by default, they're not going to be able to type in Nick Carter / and just go and visit it. And so what you can share instead is we have a gateway at hns.to. So if I go to tieshan.hns.to, this will resolve to my personal D-Link, which you can see right here. And it's fairly straightforward. And I mentioned before that the names can be used in a broader context than just traditional DNS and TLDs. What I mean by that is that you can use it for decentralized usernames for decentralized authentication. And so what we've done at news.namebase.io, it's a forum, it's basically like a normal Web 2.0 forum, except the cool thing is that it allows you to use your Handshake name to log in to websites. And so I'm just going to go in here. And you'll notice that the website URL went from news.namebase.io to oidc.namebase.io. And actually, let me see if I can get this to go slower, because I already logged in, and so it just did it quickly for me. It might just already be cached. Oh yeah, but you'll see here. So now I'm at oidc.namebase.io, and which is completely separate from news.namebase.io. And this is where my basically my credentials for tieshan.namebase are stored. And I'm using it to go and authenticate to news.namebase.io. Basically, at a high level, what's happening is news.namebase.io is issuing a challenge request for me to sign. And when I go to oidc.namebase.io, I am going to sign that message, and then it'll redirect me back to the forum so that I can go and basically verify that I'm actually the owner of tieshan.namebase. And this site will then go and query Handshake behind the scenes and make sure that the signature is a valid signature. So this is how you can actually even use Handshake names for decentralized usernames. And for a developer, this is actually pretty interesting. It's kind of similar to how you would use an ENS name or an unstoppable domains name to use as decentralized usernames. But something that's very cool is the TLDs on Handshake are all managed on chain. The SLDs, as we call them, so the second level names, the subdomains, these are all managed off chain. And so what's possible is if you want to have maximum security, maximum decentralization, you can have your decentralized username information all stored on chain and manage it that way. However, if you're a developer and you're trying to onboard users and you want to give them all their own decentralized usernames, that can be very costly. Although on Handshake names, are much cheaper to register than on a chain like Ethereum, because Handshake is built specifically for naming, and so all the transactions are all for basically registering names on chain. And so you can register names for as little as 1 to 10 cents right now. But if you're trying to onboard millions of users, that can still add up quite quickly. And so what you can do is, in this case, what we've done is we've pointed Namebase to which is a TLD that we own on Handshake, to a name server, and then we store the records of the second level names on that name server. And you can imagine, as a developer, then what you could do is you can create a application that uses decentralized usernames. And for the majority of users, you can just give them a free username, right? Like let's say you own, .app name, you can just give them username.app name, and they can use that by default. And then if they want to go and maximize their portability and decentralization, they can go and get their own, root level name and use that themselves. And the application will still just work as normal. And the analogy is it's kind of similar to getting an email address, right? You can go and get a Gmail address for free, and then it's going to be at gmail.com, or you can register your own domain name, which costs a little bit more, and then go, but it's also more customizable. And then you can go and use that as your email address instead. And so this is something that's possible using Handshake names today, which you're seeing in this live demo. And then if you're interested in actually implementing it, we have docs at docs.namebase.io, which basically shows off how to, one, create like a simple decentralized website, like I showed off here, and then two, how to use Handshake names for the decentralized authentication, which can be used, for basically any application that's trying to leverage decentralized usernames. And I'll say one other point about Handshake in case there's any non-developers here, or just people who are kind of just interested in the decentralized username space in general and collecting. Something that's been very interesting emergently is just the fact that a lot of people have been collecting Handshake names, which is kind of a weird thing because you think, oh, these are just like TLDs, so like why would they be collecting them? But a lot of not just like crypto enthusiasts, but traditional domain industry enthusiasts have gone into collecting Handshake names. And so what we've been seeing at Namebase is we have basically a secondary marketplace for the names. And basically it's been growing exponentially for the past 12 months. June was the second highest month of volume ever. Basically the volume has been growing at 32% month over month for 12 months straight. And there's a really interesting market arising from these names that was kind of surprising. Like we didn't really expect this to happen at all, but a lot of people are selling names. The person who sold .p for Namecheap, they bought it for like $5,000 and then sold it for $250,000 6 months later. And a lot of people are actually having like 100x sales or 1,000x sales. And you'll see even in the marketplace today, I'll just scroll down to a name I was looking at earlier. You'll see this double emoji name, which is using the browser's Punycode rendering, which is basically turning an alphanumeric string into an emoji. This name was originally bought in December of 2020 for basically 0 HNS. The first person, the top bidder was 10 HNS, and then the second bidder was 0 HNS right here. And so they actually pay the second highest bid, which is 0 HNS. And then they later sold it, less than a month later for 12 HNS. And then the person who bought it then sold it a few months later for 400 HNS. So there's this really interesting market. So if you're a non-developer, I would check that out because a lot of people are kind of getting into it and just using it as a game, basically, where they can make money from it. But then as a developer, something that's really cool is now that there's a lot of people who are actually registering these names and collecting them, you can build dApp experiences around them, leveraging the decentralized authentication, like I mentioned, or just creating experiences around creating decentralized websites.
Thanks, Tisha. This is fascinating. I think there's so many different aspects to the naming space that are going to be important for the web to come. I think it was like the early 2000s. I was at Mozilla for a long time, and kind of like the catchphrase of the organization was choice and innovation for a long time, and that's something that I'm seeing here, like even in a couple of hours of talks of these different projects, especially in the naming space. There's a lot of choice and there's a lot of innovation happening. We're seeing innovation at a bunch of different layers. And I think even today in the couple of talks, we've seen innovation at the application layer, innovation at the root domain layer, and seeing markets pop up that are less centrally controlled than the naming approaches that we have today. So thanks a lot for joining us and sharing about Handshake. It's great to meet you, and we hope to see you around.
Great, thank you.
Yeah. Next, we have, in that vein, more choice and more innovation. I'd like to welcome Jimmy from Unstoppable Domains, who will be speaking about things that they're building. We've worked with them in a couple different projects, and they're talking to folks like Brave and Opera. We're seeing some cool things happen there. So excited to hear what's coming next.
Thanks, Diedrich. Thanks for having me, and thanks to the Protocol Labs for being good partners as always with Unstoppable and allowing us to be here. So like what Dietrich said, my name's Jimmy. I am a PM here at Unstoppable. And I say I have the best job, probably at Unstoppable, because I run the developer tools team. And what that means is I get to spend a lot of time talking to folks in the crypto community, talking to devs, and essentially just getting their thoughts on, Unstoppable, how we can better provide value for them and how we can build tools in order for them to more easily use our decentralized domains. So happy to be here. And I'm going to quickly talk about two things in my time here. One is I'm going to talk about a little bit of the vision of Unstoppable, which, given that I'm going after my friends over at Handshake and ENS, a very similar vision in terms of decentralized naming space. And the second thing is I'm actually going to talk about how browsers can get more involved in Unstoppable and actually use these decentralized domains in order to browse websites and a slew of other use cases. So I'm going to share my screen. Cool. Dietrich, can you see this?
I can.
Awesome. Cool. So yeah, just going to start a little bit about the vision. And how do we kind of think about onboarding the world in a decentralized web? That's kind of the mandate of what's happening in our company. And it really starts with a pretty broad problem statement, which is around, when you think about the internet, when it was really trying to shape up in the early 90s, it was kind of the Wild West, a lot around the ideas of being open and being permissionless, designing protocols like HTTP, TCP, IP, and the such, thinking about how we can do composability and sharing information in a really permissionless way. And flash forward 30 years, a lot is honestly changed. And this isn't exactly the internet that was envisioned when we tried to create it in the early 90s. And so, users don't really own their data. There's censorship as a result of it because these companies own it. And as a result, there's not a lot of composability. And so that's actually a super big issue. And really, it needs to be addressed if we want to open up the next wave of innovation in the internet with Web3. And so when we think about how users don't own their information, I like to pull up this funny cartoon that I saw in The Economist a couple of years back, where it's essentially these large tech companies mining our data, right? And that's because these companies, these applications, they own our data, right? And so we are not the users, we are definitely the product. The more we use their free services, the more information they can have to sell to their true users, which are advertisers. And that's kind of a really sad kind of dystopian like view of the world where we're essentially like batteries for these companies, right? Kind of like the Matrix, but more of in a data kind of digital sense. And then when we think about what that means when companies own our data, that means they could do literally whatever they want with it, right? And as a result, when I look at the 4.7 billion people that use the internet, they're using it at the permission of these companies, which is pretty crazy to think about. Like we are only able to use the internet as it relates to the rules of these companies. And so I'm actually pretty involved on Twitter, as is I'm sure many folks in the crypto space. And I actually got flagged because I liked too many tweets. They're like, hey, like you look like a bot. You like things too much. Like you can't like things for the next 3 days. And I was like, wow, like that's actually ridiculous. Like I can't be passionate about liking things on Twitter because Twitter thinks that's bad behavior. And so when you think about like a centralized internet, that ultimately leads to a lot of counterparty risk, right? Like what I mentioned with Twitter, but it can get a lot worse than that. And so last year we saw GoDaddy employees get phished, and the result that led to a DNS attack to a couple of crypto companies, one of them Liquid.com. And so that was like, not something that a crypto company which champions decentralization ever thought would ever happen, right? But that's kind of the exposure that you have when you're using a a domain system that resolves in DNS and that's owned by a centralized company like VeriSign that owns .com. And then similarly, an Iranian news station just a couple weeks ago actually got taken down by the US, even though it's an Iranian news station. They have absolutely nothing to do with the US, but they use a .com domain. And so the US could have, they went to kind of the true owners of those domains and said, hey, shut it down. We think this Iranian news site is actually spreading fake news, which is pretty crazy because I'm pretty sure this Iranian news site never thought this would happen, that the US government could take down their website, but it's definitely the case. And so how do we kind of stop this? How do we really achieve the vision of Web 1.0 that we wanted to do 30 years ago? And that's through decentralized web, right? How do we make it permissionless? How do we make it self-custody? How do we make it censorship resistant? It's a really good vision, but like, how do you actually do that tactically? And that's kind of where unsolvable domains comes in. And we really believe that domain systems that are minted on the blockchain are a true gateway and a true foundation to Web 3.0. And so something that's user custody, that someone could just own these domains, and when you want to resolve it, it doesn't actually go to a centralized DB like what happens with .com and DNS, but actually it's a decentralized registry that lives on some sort of decentralized virtual machine like Ethereum in our case that we built on. And so what do you do with domains in order to build this completely new internet? Well, the short answer is you can do a lot with it, but the three things that we've kind of been building as a company, and I can talk more about what other people can build going forward, but we're building three things. And so we're building a use case for decentralized websites. You can use it for crypto payments. And of course, you can use it for kind of this broad bucket of decentralized identity, which a lot of my colleagues today, here today at the workshop were kind of talking about. And so 0xgym.crypto is my domain name that is minted into the unsolvable domains registry smart contract on Ethereum. And I do all three of these things. So really awesome. And I own it. And yeah, I love it a lot. And so what does it mean to create a decentralized website? And so, it's not just with a domain. And that's why I think we have such a good partnership with Protocol Labs is it needs to be a full stack, right? And so the domain is important, but what you resolve is equally as important. And so a lot of our developers choose to use our domains, but also choose some sort of backend hosting solution, or they use /choose IPFS in order to host that content. And so we have dApps like Kyber who have kind of like a light version of their website that are running on Unstoppable. We've also built a slew of kind of no-code tools to kind of bring in mass adoption for decentralized websites. And so we have an NFT gallery that reads your MetaMask or whatever non-custodial wallet and displays the NFTs that you have there. And we also have a bunch of blog templates. And so, kind of like how WordPress really led the way for this slightly no-code vision for websites, we're trying to do that for decentralized websites as well. And also, they make payments easy, as I'm sure a lot of people have experienced. These kind of long alphanumeric strings for your ETH address or for whatever kind of layer one crypto address that you have is like really confusing. And so to be able to abstract that into something as easy as 0xgym.crypto, that's a huge help for people and definitely going to bring in more adoption of folks who want to use cryptocurrencies for payments. And here's an example of how that's happening in one of the wallets that have integrated with us. And so, you can buy an unsolvable domain on our website. We have a pretty kind of full-featured experience that you can do in order to search any domain that you want. We actually recently just launched brand new TLDs. So we launched 8 new ones, .x, .mt, .dao are personally my favorites, but we have a whole slew for anyone that's interested. But I think what's really cool is that it's not just us that's doing it. Like anyone could really tap into kind of this kind of like domain reseller process. And so this is an example of my Ether wallet. They have connected to it. And so any one of their users can go to the My Ether Wallet app store and they could purchase Jimmy123.crypto and if they wanted to natively on their app. And so that's something I'm really proud of, not just us doing it, but getting other people involved and tapping into this new wave of decentralization. Yeah, and we have some numbers here, over 1 million domains that we've offered. Like what Dietrich mentioned, we work with Opera, work with Brave, And so really happy to have over 300 million potential browsers that could be viewing these decentralized websites. We have over 50 apps that are supporting us. And so that's something that I'm personally really proud of as a PM of the DevTools team. Yeah, and a lot of these names that you're pretty familiar with. So yeah, now is the right time for blockchain domains. Again, censorship is at an all-time high. Loss of trust in institutions at an all-time high with things like internet censorship and with things like the lack of ownership of data. And so I love to end with this quote from Brewster, who's the founder of Internet Archive, saying, let's lock the web open for good, because what was founded in Web 0.0 was an awesome vision that kind of got mutated a little bit in Web 2.0 with decentralized big tech companies, but we with crypto can kind of unlock it again and keep it unlocked. So that's something that I'm really proud of being a part of Unstoppable. Cool. And so now down to the brass tacks, how browsers can actually use Unstoppable, right? Like here's this lofty vision, how you guys can get involved. So the core kind of use case that we have for browsers is basically just domain resolution. And so here you'll see GIF/GIF for Brave, where you can enter into brad.crypto, which is a NFT gallery that Brad Kim, our founder, or a co-founder has. And then we also have Kyber Networks light website on kyber.crypto, so you can see their decks there. And so that's kind of like the end output that a lot of browsers can do in order to build and get access to the decentralized web that Unstoppable Domains is building towards. And so now I'm going to go through a quick walkthrough and demo. And so the demo guides were not super kind to me today, so my environment, I wasn't able to set up my environment properly. So what I'm actually going to do with you is, kind of step in the shoes of a new dev, like what he or she would need to do in order to actually integrate their browser for domain resolution with Unstoppable. And then I'm actually going to show you the source code of what I was going to run and kind of show you a really, really just like lightweight way of doing domain resolution, just to show you that you can do it in 5-10 minutes if you really wanted to. Cool. And so in order to do that, let's say I'm a new dev, just go on unstoppabledomains.com to our homepage and just go to our doc site. And then when you're here, you kind of have this like open, like this kind of like, what do you call it? Landing page that can help you like achieve the objectives you want to achieve with your documentation. So if you want to learn more, if you want to add it for payments, in this case, we are web browsers and we want to support domain resolution for Unstoppable. So I'll click this hyperlink here. Wow, internet really slow. Cool. And then I'm a JS developer, so I'm just going to go to our resolution library and go to our Git repo. This README is going to be really, really hands-on. We work really hard to ensure it's pretty easy for folks to ensure how you can set up your environment, download dependencies, and also just run a few sample commands in order to actually resolve domains in your browser. And so the first things first, you want to look up just any sort of crypto address. And so this code right here is pretty simple in terms of allowing you to see if you can already do resolutions with some sample kind of Unstoppable domains that we have. And so here you can see that we have some examples on ETH, on ZIL, and also if you want to do multi-currency, like for Tether, you can resolve that as well. Secondly, most importantly for browsers, oops, I don't know what I'm doing. You want to find the IPFS hash. And so if you're a dev and you want to host some content on IPFS and be able to access it through Unstoppable Domains, this is a way for you to hit a domain and actually have it resolve into an IPFS hash. And so this is the code right here that you just copy and paste. And so right here, if you want to run that function, if you want to do homecakes.crypto, actually we even have a console log here that shows you that this is the hash it's going to return, and this is actually how this is how you actually use the hash in order to view content. And so it's super straightforward. That's like literally all you need. If you wanted to do something that was a little bit more bespoke, like you can run a command line interface, or you can actually read it directly from Ethereum if you're more proficient in peering with Infura and reading from the blockchain. But we try to make it as simple as possible for anyone that just wants to hack together like in call it like 5 minutes or so. And one thing that I wanted to flag is, so what we do in this Git README is that you can essentially just resolve domain names to IPFS hashes, but you don't actually return a website yet. And so there's kind of 3 ways that you can use this code, actually return an IPFS hash, and have that hash actually turn into a content that you can view on a web browser. And so one of the ways is you can literally just add this gateway URL and append the hash to it. And so if you go to brad.crypto, you can see here that that's literally what we did. So we went to this IPFS gateway and just appended the IPFS hash. The second way you can do it is if you want to do more programmatically, you can just go into the IPFS docs and go to their gateway, and then you can use a variety of other gateways that are using outside of their public one. And then lastly, if you want even more security and more kind of programmability, you can go to the IPFS JS Git repo. Again, this is if you're using our resolution JS library, and then you can have a lot more customization. And so that is essentially as easy as you need for any developer who has a browser that wants to add domain resolution for unstoppable domains. And so lastly, what I'm going to show you guys is just a really quick code example that we hacked together in literally less than 15 minutes. And just to show you that, nothing pretty, but this is a really, really easy way for you to add domain resolution for your browser. And so you can see here, we just have a very standard React boilerplate here for TypeScript. And then we're also, importing this unstoppable domains resolution library. You can see here that we're essentially just having a function that inputs some sort of arbitrary string. And then it's actually pretty interesting because in the example that I gave in the docs README, that mainly resolves an IPFS hash, but we can also resolve DNS records with our domains. And so here in this code, you can see that we're actually resolving either a DNS record, or you can also do an IPFS hash. And then finally, you're just showing that record. And so if it's DNS, you need to show this JSON blob. If it's a hash, you can just show it as a string. And I wish I could run it, but the demo gods hate me today. But hopefully, if you're seeing the code, you can see that this is literally as hacky and as easy as you can to do domain resolution. So hopefully, people can participate. Cool. And then I know I'm a little bit over time, so I'll just end with a few slides here. And so one is just highlighting our bounties. And so any browser that wants to integrate unstoppable domains will give out $2,000 per winner. And then anyone that wants to use just an unstoppable domain for your project. So let's say you're not a browser, you don't want to do domain resolution like what I just listed. You just want to get a crypto domain, a .crypto domain, and you want to host your app through IPFS through this domain. We'll give people $100 in store credits. Cool. So that is it. Thanks. And if you guys are interested, please go to our docs. Please go to our Discord, which is also in our homepage link. If you guys have any questions or support, or if you just want to talk to some really cool devs building some really cool stuff on Unstoppable and on the decentralized web. Cool. Thanks, guys.
Thanks, Jimmy, for joining.
I talk really fast.
No, it's fine, and I'm just kind of mind blown at how many cool choices there are for developers today, and also like the differentiation between the 3 different naming systems that we have. Speaking, like it's just a very different world than even 2 years ago or 5 years ago, let alone talking about 10, 20 years ago. When I was first started paying the VeriSign Piper and things like that. So thanks for joining. Great to see you all. And we have one more talk today. I would like to introduce another new friend I am meeting for the first time, and I'm super happy to have here to present some of the work that is happening at Brave. Aniruddha, please share what you have to share with us.
Yep, going to share my screen. Okay. So can you see my screen?
We can.
Great. So first of all, shout out to Jimmy from Unstoppable Domains. We had a native integration of Unstoppable Domains in Brave maybe a couple of weeks back. And I think it's a really, really good use case of decentralized applications. I really like it. I think it's the future. So it's great pleasure to be here and sharing some of the exciting developments in our favorite privacy browser with respect to crypto and Web3. So my name is Anirudh. I recently joined Brave as a wallet engineer. Prior to that, I was working for a couple of years on institutional crypto self-custody at Ledger. You can find me on Twitter, where I'm mostly talking about crypto, of course, and posting some mindless memes. And yeah, so I want to start by first presenting a quick overview of our products, who we are, what we stand for, and so on. So Brave is a privacy-focused browser where you're not a product. It's blazing fast. You don't see any ads. It has a great native ad blocker. And one of the things you can do in order to test this is simply visit a shady website. And I can assure you that you won't be disappointed. In fact, I don't remember the last time I saw any ads. Recently, we launched Brave Search, which is a search engine that doesn't track you. And we've been receiving overwhelming response from the community, and it really shows that people want alternatives that are privacy centric. So if you have not tried this already, head over to search.brave.com. And from what I've talked to people who have used this, usually they end up setting it as the default search engine. But feel free to try this. And if you have any feedback, let me know. Brave also has an opt-in ad economy that rewards you for browsing the internet. Couple of things to note here. First, it's opt-in, so you don't have to participate in this economy that pays you tokens. It's known as basic attention token. And the other important thing is that ad targeting is completely anonymous and is done in your browser. So on the device, your user data and everything, it doesn't leave the device. So it's really privacy centric. And in fact, quite the opposite of how the entire ad industry is working today. And finally, we have a growing ecosystem of users. The reason why I want to talk about this, while you may say these are rookie numbers when it comes to web scale, imagine shipping a crypto wallet to 33.8 million users, monthly active users. So they have access to sound money. And that is exactly what we are trying to do. So we are building a native crypto wallet that's designed for every internet user. And if you think about it, a browser is something that every smartphone user, like every internet user has. So it's a great opportunity to give access to people to store, send, receive cryptocurrencies, access sound money basically, and be able to do that in a non-custodial and permissionless way. So you don't have to call anyone, you don't have to seek anyone's permission. It's just, this is empowerment in the true sense. So a couple of things on top of which we are building Brave Wallet. So for those of you who have already used the legacy crypto wallet in Brave, it's an extension that loosely integrates with the Brave browser. It's a fork of MetaMask. It's a JavaScript Ethereum remote client. And it's really quirky, not as fast as it could have been. And these are the things we want to fix in the new Brave wallet. So it's going to be native. So it's lightweight, doesn't rely on an additional background process, is less memory intensive, and entirely written in C++. Of course, it's going to be non-custodial. So not your keys, not your coins, and users are always in control of their private keys. It has some privacy features actually by design, because what may seem like a surprise to some of you, there are a lot of wallets, in fact, most wallets, that send out extended public keys of your wallet to a third-party server in order to, especially for Bitcoin accounts. And what this allows them to do is not just figure out what your addresses are, but also figure out all the future addresses you're going to have. So it's a privacy disaster. This is something that we would like to correct in the Brave wallet, because privacy is something that's not an afterthought. It has to be there by design. And finally, it's going to be a multi-currency wallet. Of course, we are going to support Ethereum, EVM compatible chains, but additionally also Bitcoin and maybe other chains going forward. So I know this is a developer focused talk. We want to learn something new, deep dive technically into wallets. So that's what I'm going to talk about, starting with elliptic curve. So the reason why we are covering this is to really understand what wallets are, how they work behind the scenes, and what it entails to design a wallet. So just like a square, triangle, circle that has an equation, elliptic curve is also a set of points that satisfy some equation. For example, y square equals x cubed plus x plus b is a elliptic curve equation that's quite popular. It's not the only kind of curve out there, but it's the one that's most popular, used by Bitcoin and Ethereum, probably also Zcash. In fact, the browser that you're using right now, the HTTPS, is most likely secured by elliptic curve of the same family. And the values of A and B is chosen, they're chosen in a way that that gives interesting properties to the curve and makes mathematical operations on the curve efficient and cryptographically interesting. So this is what a curve looks like on the right-hand side of the screen. Feel free to go to Wolfram Alpha, put in the equation with different parameters. It will show some funny shapes. Also, brings us to the next point is what is a public key? It turns out that each point on an elliptic curve is actually a public key or a public point. Like with any point, it has an X and Y coordinate. So when, let's say in future, someone asks you, hey, can you send me your public key? Remember that it's just X and Y. Serialized in a certain manner, but still X and Y values. These values are simple 256-bit integers. And the way it's derived is by taking a random number that's supposed to be private and performing repeated additions of a fixed point. Could be any point on the curve. So you take any point, repeatedly add to itself certain number of times, let's say k, it gives your public key. So in this example, k becomes your private key and p is your public key. And needless to say, you should not reveal k. Maybe this is something that all of you are more familiar with, which is an address. What if I tell you that address is just a representation, a minified representation of the public key? So if you have an Ethereum account, I believe a lot of you have Ethereum accounts, you have a designated slot on this elliptic curve. And you can be rest assured that there's a lot of space for all of us. It's pretty straightforward to generate an address. Just take your public key, get the Ketchak 256 hash, and take the last 20 bytes of the resulting string, and that gives you your address. So in case of Ethereum, you just have one address per account. With Bitcoin, because you don't have account abstraction, addresses, a bunch of addresses will represent all the funds that belong to your account space. But the general concept is still the same. So recall that I was talking about a private number that you must not reveal to anyone. Well, if you have 1,000 accounts, you have to remember 1,256-bit numbers, and this is not easy, right? You can lose you can lose this number easily, and it's hard to back up. So some people came up with a clever algorithm called BIP32. It's standardized in Bitcoin, and all blockchains are following the same standard. And what allows you to do is randomly generate, like use a combination of 24 or 12 words, word mnemonic. It should be generated in a cryptographically secure way, and use that to obtain a seed, followed by a master private key, and then as many child private keys as you want. So potentially millions of accounts, if that's what you want to generate. Just by having 12 words, you get access to as many private keys as you want. So again, this is something that you must keep a secret. So that's about, we discussed the mathematics of wallets. But in order to be useful, they have to do something, right? And especially in case of Ethereum, we have dApps, and dApps want to access your account data. They want to get your address, your balance. They want to request signature on transactions or personal messages and so on. So wallets must provide an API, and this is formally known as the Ethereum Provider API. So Brave, the Brave wallet is natively exposing this via the window.ethereum JavaScript object. And it also allows you to subscribe to certain events in order to get notified of changes to your accounts. So your wallet must be able to speak Web3, the Web3 language. Okay, what else? We know that in the Ethereum world, it's a state machine. It's a giant state machine. And what state machines do is transition from one state to another. In Ethereum, this happens by executing transactions. So these transactions must be serialized in a certain format, and so that they can be efficiently transmitted over the wire and can be interpreted in the EVM. So the format to do that is called recursive length prefix, or RLP. It's like protobuf if you've used it before, except that it just encodes the structure and doesn't encode the underlying types. So if you're designing a wallet, it must be able to speak RLP. It's quite similar in case of Bitcoin. You must be able to speak something called the wire protocol, which is just a set of rules for encoding Bitcoin transactions. So it's similar in intent, but different in design. As you can see on the right side of your screen, it has inputs and outputs. It suits UTXO-based currencies. So now that we have done a deep dive, let's look at how it looks like when we package all this in a beautiful UI. This is how it looks like. Now, this is not the final version. It's actually pretty outdated. I can assure you it looks much better than this. But so this is how it looks like on the desktop side. These are some screenshots of how it's going to look in on mobile. So you have the portfolio, you can buy, you can swap using a DEX aggregator, manage your accounts. And regarding features, just highlighting the important ones, it's going to have hardware wallet support. So if you are security conscious, as you should be, you can verify and send transactions on a ledger or your Trezor hardware wallet. It's going to be available on all platforms supported by Brave. So if you have a browser, you have a crypto wallet. That's the idea. So on desktop and mobile. Something really cool is you'll have native permissions. So just like giving access to geolocation on the browser, in the same way, dApps will be able to request permissions to the crypto wallet, and it will use the native permissions framework that's available in Brave or in Chromium. And finally, NFTs, because why not? Maybe you have a bunch of NFTs, you don't know what to do with them, might as well view them in your gallery or show it to your friends or colleagues. I think we can have a pretty good UX around that in the crypto wallet. So that's it. It's coming soon to your browser this year. And if you have any feedback, feel free to reach out to me, especially if you have anything related to crypto, any question, something you would like to see in the upcoming crypto wallet. Feel free to talk to any one of us or me on Twitter, and we'll happy to talk to you. Thanks a lot.
Thanks, Aniruddha, for joining. Great to meet you.
Yeah.
Great to learn more
Likewise,
about
yeah.
the inside of the wallets that we see the outside of typically. Yeah. So thanks for sharing that. We're super excited to see what Brave comes up with next, and it's great to work with you all. So that actually concludes our set of speakers for today. Thank you all for joining for Browsers 3000. We got a sneak peek into some things that are coming up. We saw a bunch of code actually that works and runs today, which was really inspiring, and really more than I expected, and a bunch of brave souls that were willing to test the demo gods and run their code in front of you all. The hackathon is open now. We will have learning sessions from a bunch of these people over the next few weeks. You can learn more, build along with them, try some of these things out, and be a part of making the web of the future that you want to see happen. Thanks everybody who came to speak. Thanks to our event folks who handled a whole bunch of speakers in a very short period of time. And thanks to all of you watching on the live stream. Looking forward to seeing you at the hackathon. Join us over the next couple of weeks. Have a great day. Bye-bye.